This meeting is being live streamed. We have a choice to either do got it or get out of here.
Or get out of here.
David, you said yes 74 times in a row. Are you really going to say no now?
No.
No. David Levy is a huge part of Global Star Party, I think.
Not as big a part as I used to be because I've lost a lot of weight.
From all the effort of doing Global Star Parties?
Yeah, I've lost a lot of weight. I think I've lost about 15 pounds.
Wow, I need to lose
15 pounds.
15 pounds less of David right now.
They called it the quarantine 15, so yeah, it's but gosh,
how come the amount of weight we gain or lose?
What's that?
How come the amount of weight we gain or lose always has to rhyme?
I don't know.
Sorry, just popped into my head. My apologies. Without Nathan here tonight, I figured I have to be the one to come up with witty things on the fly.
So Nathan will be on tonight?
Oh, no, I said without him.
Without him. Yeah.
But he is interested in coming back soon. He said he's going to start putting something together right away.
He was just so funny. I mean, it's just great, so.
He stayed on the entire evening. He came in straight after school, logged in, and then stayed with us.
I think he liked it. So.
He did.
Mm-hmm.
What's not to like?
Exactly.
Yeah, how could you not like this?
Right. Yeah,
it's more fun than you should have on a Tuesday night.
So Harold Block is the first one to log in on chat this evening.
Hello.
Yeah.
Harold is.
So we had, today I was supposed to be on QVC. Well, I was on QVC, but I was supposed to be on at 2 p.m. Central. And we're all set. We're in the showroom, we've got 2 cameras set up and everything. And I'm mic'd up and I've got earbuds in and stuff. So I can talk to the show host over at QVC. And we're supposed to go on the air at 2 o'clock sharp. At 2 o'clock sharp, the internet goes down. Boom. So we're scrambling, we're going crazy. And we end up, we have a pretty good high-speed internet at Explore Scientific. But we cobbled together one of those hotspot connections, so we're like rifling through office drawers and stuff. We find one of these things and it gives us only 15 megabytes up and 15 down, so we're going, I don't know if this is going to work. And so they don't call us. And so I'm driving home. As you can see, I'm home right now. Okay. Because we still don't have internet at Explore Scientific. And so I started getting Skype calls. That's how they contact us, is through Skype. And I'm getting Skype calls from the producer at QVC as I'm starting to drive home. So I whirl back around. We connect up all this stuff. They say, oh, yeah, that high-speed internet stuff that we talk about, don't worry about that. We can hear you. We can see you. And so they put me on. So that saved the day. But anyways.
Very glad to hear that. And hello, Adrian.
Hello, David, Karim,
Adrian.
Mike, and Jerry, and Scott hiding behind.
Hi.
This is the famous Dr. Adrian Bradley.
That's
famous
right.
Astrophotographer.
Mm-hmm.
Yeah, it's early on yet. Maybe I'll get there. I just have to keep up with the passion of doing this.
Oh, we don't have to anymore. David is giving out honorary degrees.
Yeah.
If it comes from David, then it's official. And I will hang that on the wall.
That's right.
So Scott, it's almost time. I keep trying with this Star Adventurer, and my tracking is off. So pretty soon I'm gonna have to finally go and get the Explore Scientific one of the small tracking mounts that you've got and
We've had
start
some
showing it off.
pretty good luck with it so far. So you know, we had a guy get like 0.3 arc seconds of tracking with, of course, with guiding. You know, so
Yeah,
but
That's
yeah,
a
guiding would be.
$500 mount.
Yeah, well,
Because I'm that guy.
$500 to a guy who's had to spend 2,000 on the camera. The mount would be worth being able to track for a lot longer than I'm getting right now. So it's
Yeah.
either that or haul out a Losmandy mount and figure that one. I'm gonna go with the smaller mount because I like to travel and I like to just pick up the whole tripod, throw it in the truck and go. So
sure.
Is that Adrian?
yeah, it is me, Tyler,
What's up, buddy?
doing good.
So speaking of guiding on the IXOS 100, Jerry can attest to this because I've told him the same thing. I've been able to get, with this setup that's back here behind me,
Yeah.
0.4
Okay.
arc seconds for guiding. It's just with a decent polar line, but rough balance. I just make sure that my tripod's level. People that say that it doesn't matter, are full of it.
Yeah.
I mean, it all matters. It's the fundamental that you have to start out with. But just balancing.
It's the way they say it doesn't matter. If you do it the way they did on meatballs, you just go up and you say, it just doesn't matter. It just doesn't matter. No, it doesn't matter.
But I mean, this little thing back here, Adrian, if I can walk you through it, how to set it up. I use the ASI Air up here.
Yeah.
And it's dummy proof. It's literally dummy proof, and it makes it simple, especially since you travel. And that's the reason why I got this, is for just the ability to travel anywhere and just set up in a matter of minutes.
That's the goal. Yeah, I'll have to stay and check out your where are the presentations, by the way? Let's see, Tyler. So yeah, you come on after the break, so I'll be hanging around and checking out the presentation. So what I'm able to do with the Star Adventurer used to give me a minute up to 2 minutes untracked.
Yep.
There is a chance that I might have beaten it up a little bit, going here and there and having it ride in the back of the truck, but the tracking right now barely does 30 seconds. And that's if I do half sidereal tracking, so I can have a single frame. I still have these annoying star trails. So I'm still trying to figure out if it's the lenses that I have or just the fact that I'm just not tracking very well. And I've tried to make sure it's all balanced and everything, like you said, that the tripod is level.
What camera are you using?
I'm using a Canon 6D most of the nights.
So full frame.
Yep, so full frame. Yeah, all I have is full framed I put on there. If I'm not using that, I'm using a A7R4 from Sony, which has recently jumped in and stolen the crown of unmodified camera to use for wide angle shots. So if the 6D is modified, so if I want the afro around Orion's head, I use the 6D. And Bernard's loop. I think it's Lambda Orionis is the official name of the title, but I want to submit Orion's afro to the IAU and see if they'll allow that. I'm sure I'll have a fight on my hands, but I think it is. In fact, now I'm going to pull out an image so that I can show that if I'm within my time, I can say, see, it's Orion's head.
house-sized particle. Well, hello everyone. This is Scott Roberts with Explore Scientific and the Explore Alliance, and welcome to the 74th Global Star Party with the theme of Lookback Time. Lookback Time is a term that's given by astronomers to describe the effect of seeing something at whatever distance it is. However long light took to travel to you, that is the look back time. So if light took a couple of seconds to get to you, then the image that you're seeing of that object is 2 seconds old. It's not in real time. But as we look further away, maybe a few miles, out to the distance of the moon, or maybe out to the planets, now we're starting to get out to light minutes. I think it takes 8 minutes and change for light to get from our sun to the Earth. When we observe the sun, we're seeing it at 8 minutes ago. When we turn our sights to the Andromeda galaxy at 2.2 million light years away, we're seeing Andromeda as it was 2.2 million years ago. And also at the observable distance of where it was 2.2 million years ago. So we know that we're on a collision course with the Andromeda galaxy. So if we could see it in real time, things would look different to us. But we don't see things in real time, and that is the look back time. It is a concept that fascinates a lot of people because when we see a supernova or something explode in a galaxy, we know that if that galaxy is millions of light years away, that supernova star took off or exploded that many millions of years ago. fact that we're getting those photons, the real photons during, during that episode, doesn't mean that that effect isn't with us anymore. It is, but the star itself in real time is maybe not there, or some remnant, a black hole or neutron star or something is there in its place. So, but anyhow, it is very fascinating. It's something that I bring up a lot during astronomy outreach programs, and is just one aspect of understanding the universe that you're observing. Well, tonight we've got a great program lined up. We're close to Thanksgiving, so some of our friends are not with us, but others are, and they've made that commitment, so we're really happy to have them. Of course, up next is going to be David Levy. We've got Chuck Allen from the Astronomical League. He'll be with us. Karim Jaffer from the Royal Astronomical Society Montreal Center. Royal Astronomical Society of Canada Montreal Center will be with us. Adrian Bradley with his Scapes. Molly Wakeling is committed to be with us. Hopefully everything's working where she can show us live imaging from her backyard. Mike Weasner is going to be talking about dark skies with us out in Arizona. We'll take a 10-minute break, and then we'll come back with Tyler Bowman from his observatory, Jerry Hubbell from his observatory, Annie Scarborough, who's not yet participated on a global star party, will be talking about exploring the stars with her family. So that's pretty cool. Marcello Souza from Brazil will be on with us, and he'll be talking about the Young Stars of Tomorrow program, their program of inclusiveness, and Skies Up magazine. Nico the Hammertime with Nico will be on. César, Brollo, Maxi, Falieres, all three from Argentina will be very interesting. And then we'll take another 10-minute break and any after party that might happen afterwards. But we're glad you're with us. I may or may not have mentioned that I'm broadcasting from my home, and the reason for that is that the internet is out at Explore Scientific, so I had to reconfigure everything for here. But we got a great audience too watching. Pekka's on. We've got Harold Locke, Jacqueline Arndt, and the Dad Frequency, Lisa Ann Fanning, and others are watching. So welcome to Global Star Party. And I'm going to turn it over to a fabulous person who has just now made us all honorary, given us honorary PhDs, Dr. David Levy. So that's great. We all wanted a PhD tagged on to our to our name. But David, thank you so much. It's great to have you on for yet another Global Star Party, and you've been really busy, I know, doing other events, and everybody appreciates having some David Levy time. So we'll turn it over to you, David.
Well, thank you so much, Scott. And I can no longer say that I've been to all of the Global Star Parties. I did miss one.
Just one.
And, I did miss one, and which kind of, I still feel pretty bad about that, but it's because it was not
your fault. It was not your fault.
But I'm feeling bad about it, and like to make up for it somehow.
We will make up for it.
Anyway, I'm glad to see that a lot of my friends are here. Jerry, Mike, and Adrian, and Karim, and Tyler, and Chuck, certainly from the Astronomical League. Adrian, you did mention during our informal thing just now that you were going to try to photograph an area on Orion, and you were going to try to give it a name for it, and you were hoping that the IAU will accommodate that. Well, I would like to suggest that you don't need the IAU to accommodate you on that. You can just make your own Adrian's catalog. I've done that. There's no reason that you can't do that.
Right.
So it's done.
Good point.
Anyway,
All right.
As we get into this Global Star Party, the two poets that I think are most inclined to write about time are Shakespeare and Tennyson. We've talked about Shakespeare before and about Tennyson before. I really wish I had known Alfred Lord Tennyson. I do know his great-great-grandson, Jonathan Tennyson, who is an astronomer and who's done a paper on Comet Shoemaker-Levy 9. And I did get a chance my last visit to London to meet with him. And I really think that family is still very interesting and very well worth knowing. But Tennyson, I think, Alfred Lord Tennyson was really tops when it came to writing about time, which is our theme this week. And I think there's no better poem that he did that than In Memoriam, which is definitely his magnum opus. And I'm going to share 3 passages from In Memoriam tonight. One is pretty simple. It's about the discovery of Neptune. And it goes like this: a time to sicken and to swoon, when science reaches forth her arms to feel from world to world and charms her secret from the latest moon. Little thing about Neptune there. He wrote this in 1850. Neptune was discovered only 4 years earlier. The second one is really where he gets into evolution and talks about time. Contemplate all this work of time, the giant laboring in his youth, nor dream of human love and truth and dying nature's earth and lime. But trust that those we call the dead are brothers of an ampler day, for ever nobler ends. They say the solid earth whereon we tread in tracks of fluent heat began and grew to seeming random forms, the seeming prey of cyclic storms, till at the last arose the man who throve and branched from clime to clime, the herald of a higher race to shape and use. Arise and fly, the reeling fawn, the sensual feast, move upward, working out the beast, and let the ape and tiger die. I have one more passage from In Memoriam to share with you tonight, and this is the last 4 lines of the poem. And I believe that in these 4 lines, Tennyson is doing a teleological discussion in which he actually discusses in the In Memoriam stanza if the universe will be expanding forever. And this is decades before Hubbell, not Jerry Hubbell, who we have here, but Dr. Edwin Hubbell, came up with his theory of the expanding universe. And we still aren't sure if it's going to expand forever or if there will one day be a big crunch. And I believe that Tennyson felt in 1850 that there would be a big crunch. And this is how he ends In Memoriam, that began as a simple elegy towards a friend, a very dear friend of his, who passed away at a very young age from a stroke. And he starts with that, but then he goes on and talks about where the universe is headed. And I want to end my quotation with this: that friend of mine who lives in God, that God which ever lived and loved, one God, one law, one element, and one far off divine event to which the whole creation moves. And back to you, Scott. Thank you.
Thank you so much. Wonderful. Is Tennyson one of your favorite
Oh
poets?
yeah, I think so. I think next to Shakespeare and George Manley Hopkins, Tennyson's my 3rd favorite poet.
I see. Well, great. So do we have Chuck Allen here with us?
We do.
We do. Okay. All right. That's great. Let me go ahead and bring you on here. And there we are. And I see you right there. We're going to add the spotlight to you. And thanks very much, David. And we will figure out, I'm going to figure out something very special for you that will be a special edition of Global Star Party. So more to come. All right. Well, Chuck, I know that you've been super busy. I've heard that you're very involved with some special projects right now. Terry Mann was letting me know.
Yeah, I'm in the final week of getting a draft of a book to a publisher, royalty publisher, and it's about a shark attack victim. It's an authorized biography of a shark attack victim in South Africa.
Oh, goodness.
And it covers about 8 shark attacks among his friends, 2 or 3 of them fatal, and fully interviewed accounts of those, and basically life in South Africa post-apartheid, and a little bit about surfing culture, all kind of woven together.
Oh, goodness. Were you involved in surfing yourself at all?
No.
Okay.
And having written this, I will never be involved in
You
surfing.
will never be involved.
That's right. A lot more dangerous sport than people realize for a variety of reasons, not just sharks.
Sure. I did it as a young man, but it's a thrill for sure.
Yeah.
But yeah, there everybody that surfs has stories, so for sure. Well, Chuck, thanks so much for coming on.
Sure.
And doing this for the Astronomical League, and so let's go ahead and get started.
All right, let me share screen here. It's not sharing. There it is. Okay. Whoops. There we go. Okay, as usual, folks, we like to help preserve and save people's vision, and vision can be jeopardized by astronomical pursuits that involve observing the sun. So we like to give these warnings whether we're talking about the sun tonight or not, because you might be around a telescope, or you might have kids who are around a telescope or a pair of binoculars when the sun is out. And that can be dangerous. You don't ever want to leave a telescope or binoculars unattended around children in daytime. If you're going to use any type of, if you're going to observe the sun, you need to use professionally made solar filters that include energy rejection filters at the top end, the front end of the telescope, not any kind of filter that goes on the eyepiece. And if you're using eclipse glasses to look at an eclipse of the sun, a partial or hopefully a total at some point, the eclipse glasses are meant to use alone, not with binoculars or a telescope.
That's right.
Expose eclipse glasses, as Scott Roberts can tell you, to a telescope beam aimed at the sun, and they will melt almost instantly. And you don't need that kind of problem. So with that said, we'll move on. These are the answers from the November 16th Global Star Party. Within the Large Magellanic Cloud is N44. And what was notable about N44? And the correct answer is that it was notable for its hollowed out core. This core is some 250 light years wide. The hole, called the superbubble, is a cosmic enigma. The second question was, what plans has the Orbital Assembly Corporation announced for 2027? And that's a space hotel. For those of you who ever saw the movie 2001, this will look somewhat familiar. What well-known chefs helped NASA pick the winning teams for a second phase of the Deep Space Food Challenge? The answer was Martha Stewart and Lynn Crawford. Okay. Now your answers need to go to secretary@astroleague.org when I get to the questions in a moment. The correct answers for November 16th, by the way, were these 5 individuals: Rich Eubank, Don Nab, Cameron Gillis, Rich Kraling, and Israel Monteroso. So congratulations to them. And they will be added to the door prize list for the end of the month. Okay, here are our questions for tonight. Once again, at the bottom of each slide, you'll see where to send your email with the answers. First one. This long dark feature called a filament is actually a what? Is it a prominence, a sunspot, a solar flare, a spicule, or a chromospheric arch? Okay, number 2, of the primary 8 planets in our solar system, how many have ring systems? 2, 3, 4, or 6? And number 3, Speaking of look-back time, GNZ11 is the furthest galaxy ever observed. We're seeing it as it looked 13.4 billion years ago. How far is it from us now? Is it 6.7 billion light years away, 13.4 billion light years, 32 billion light years, or 1.34 trillion light years? And those are the answers. Those are the questions for tonight. And I'd like to mention that we will have a live event number 13 for the league on December 3rd. Our speaker will be Matt Penn, and he will be talking about the Dynamic Eclipse Broadcast Initiative. So I hope you'll join us then. We have great speakers for these. Scott, thank you very much. And I'll turn it back over to you.
Thank you very much. I would like to, mention that the Astronomical League is someone that, or an organization that we've been, closely allied with, and we believe in all their initiatives that they do. They have great observing programs. They interact with the community, I think, in the best way. Not only friendship and all of that, but through education, through a lot of hard work in their almost all volunteer program. And they are the largest organization of their kind. They have over 300 member clubs that belong, that are part of that federation of the Astronomical League, and over 20,000 members. So you too can be a member of the Astronomical League through your club here in the United States, or you can, anywhere in the world, you can be a member at large. And so you have no further to look than the website astroleague.org. So thanks so much, Chuck, and we'll see you guys next week.
Great. Thank you. Thanks, Scott, for all you do for us.
Thank you so much. Thanks all you can do for everyone. Okay, so up next is Dr. Karim Jaffer. He is with the Royal Astronomical Society of Canada, Montreal Centre, and also at he's a professor at John Abbott College. He is the astronomy professor that we all wish that we had. So I'm going to turn this over to you, Karim.
Thanks, Scott. And not a doctor. Not a doctor.
Not a doctor.
But a newly minted lowbrow astronomer.
You got the honorary from Dr. Levy today. So
I did. And yes, as Adrian mentioned, I'm now a member of the Lowbrow Astronomical Society in Michigan. And so I'm a member of the Astronomical League as well. I'm now wearing even more hats.
Right.
It's more fun that way, right?
That's right.
I was so happy when Scott put the time of the topic of look back time. We talked about this a few GSPs ago, but I felt like there was so much more to talk about. And so I got really excited and started putting together the presentation I wanted to give. And then I had my class today, and my class today kind of took things a little bit sideways during class and then after class with some discussions with some of my students. And I decided to bring you on a journey with the perspective from Jack Astronomy about look back time. The last time we talked about this, I actually talked about look back time within the solar system. But what I talked about was not just the amount of time it takes for light to get from the sun to the solar system, planets, but also the amount of time it takes us to communicate with probes that are studying different parts of the solar system, and the amount of time it takes the light to actually leave the sun. Tonight, we're going to go a slightly different direction. But as always, before we do, I wanted to do a check-in with the Montreal Centre and invite everybody in the audience to join us for our next public event, which is on Saturday, December 4th, 4 p.m. Eastern Daylight Time, and it's on Apollo moon rocks. And we have a graduate student, Gavin Tolometti from University of Western Ontario, who has been researching a little bit on some of the past Apollo missions, the history, and then he actually got to be involved in a little bit of the research using current technologies to investigate these moon rocks. So he's going to talk to us a little bit about what we understand about the geological history of the moon based on all of these moon rocks that we've had come back from the moon. So you're all welcome to join us for that. And as a lot of you have noticed over the last few weeks, I've been bringing in guests from the RASC Montreal Centre as well as the RASC as a whole to come to the Global Star Parties and be with us for the evening, share with us a little bit of their wonderful insight. And unfortunately, the speaker we had lined up for tonight to join me, Kwa Tran, he lost his voice. He's been struggling a little bit with a cold that he's been fighting. And so, Kwa, we wish you the best for a speedy recovery, and we hope that you will join us for one of the future Tuesdays. But our outreach coordinator, Russell Freilich, is going to be coming on next Tuesday to talk a little bit about backyard astronomy that he's been doing. But it's right after our lunar eclipse. I wanted to talk to you a little bit about our journey here in the Montreal Center with the lunar eclipse on November 19th. Adrian and I were both also participating in the virtual telescope project based out of Italy with Gianluca Massi. And so we were trying to take pictures and send them in real time so that they could be shared all across the world. And the evening, the forecast was not great. Montreal forecast never is, but it started out actually pretty good. I even got a little bit of penumbral shadow. This was at around 1:40 in the morning, so before it had actually started crossing into the umbra. And you could see just a little bit of the dimming compared to what the full moon looked like at around midnight when it hadn't come into any part of the shadow yet. And then you got to see the start of the eclipse. You got to see the Earth's shadow starting to fall on the face of the moon. You even got to see the curvature of the Earth visible to us. And this was fantastic to see. And I was so happy and so excited. And then the clouds rolled in. And when the clouds rolled in, they started to take over dramatically before even half the moon's surface was covered with shadow. And so I was, still online and talking to Gianluca and messaging a few others that were involved in the project and watching views from places with much better weather. But one of my students decided that she kind of started to understand what it is to be an astronomer, and she was going to be patient and she was going to wait. And I'm very happy to report that Vanessa Tomasini got a picture just after maximum. And I was so happy for her. And so we shared this with the world, with the virtual telescope project, but we also sent it out locally. And on the Sunday night news, they actually showed her image, and it's the clip. That's the thumbnail that they used for their clip to talk about the lunar eclipse. So I'm very happy because this actually got not just her excited for what she saw, but it also got to be shared with our local community in Montreal and all over the world. And that's one of the things that you really hope when you're trying to share some of this passion that we have for astronomy and for amateur astronomy, is that some of that actually translates over to the students. So talking about the moon, when we're talking about Lookback Time, we have to recognize that what she was taking pictures of what we were seeing was actually leaving the moon's surface just under a second and a half before we got to see it. But that light didn't just come off the moon's surface. It's been traveling since it left the sun's surface 8.25 minutes before. So, it travels a bit, bounces off the moon, comes back to us. We capture it in our camera, we upload it, we send it to each other, and then we drop it off into a Dropbox. And then in Italy, they put it up on the web. That takes a certain amount of time. Yes. That's not exactly what we're considering when we talk about look-back time in astrophysical senses. In astrophysical senses, when we talk look-back time, we're talking look-back time. We are talking about looking far off into the distance beyond our solar system, looking at the deep space objects, and looking as far as we can possibly see. Now, ground-based observatories in the 90s were able to get out to about a distance of 6 billion years, which is phenomenal. And earlier we were chatting a little bit about the resolution that some people can get now with their observatories or even with their backyard telescopes. At that time, the faintness of light, the size of telescopes that you have, the atmospheric opacity of the Earth, all of that combats how deep you can see. When the Hubble Space Telescope went up, it expanded our vision, and the Hubble Deep Field got us much, much further out to just 1.5 billion years after we think the cosmic dawn, just after the Big Bang, when electromagnetic radiation actually was able to start to be released out of this radiative mess that came when the Big Bang had happened. The ultra deep field and the ultra deep field infrared all got us further and further. And we're really hoping the James Webb Space Telescope is a tiny setback right now, and the launch date's been pushed back by a couple of days, but we're hoping that once it's up and running and everything's running well, knock on wood, fingers crossed, whatever, walk 3 times counterclockwise, whatever you have to do for superstition, we're really hoping that we get fantastic data out of the James Webb Space Telescope. But when we're looking this far away, what we're actually trying to look at is not the material the way it is now. We're trying to look at how it was when the light was released from those objects. So when Chuck talks about this most distant galaxy that we're looking at, it's important to recognize that everything you see, the image that you're viewing, that light left that object a certain number of years ago. And so when we're looking 6 billion years out into the universe, we're looking at something the way it looked 6 billion years ago. And it's been moving ever since then. And so since it's been moving ever since then, where it is now in the scale of the observable universe now is different from the amount that we can actually visually see. And so when we talk about look back time, the astrophysicists and the astronomers are really trying to deal with one of the most complicated things, the hardest thing it is for any astronomer to measure. When an astronomer goes out there and they set up their telescope, whether it's a radio telescope, whether it's a space telescope, or whether it's your own little refractor or reflector in your backyard, your job is to catch photons and figure out how to resolve the detail within those photons. And those photons of light, that little bit of information, that shows you what the object looked like when light left it. But where is that object is something that's a question. The distance measurement is incredibly difficult. And so we have to have different tools for measuring distances. And we've developed a whole set of tools depending on how close an object is versus how far away that object is. And in 1929, Hubbell released his first set of data trying to understand the relationship between distance and the speed at which these galaxies seem to be moving with respect to us. And that was based on measurements of Cepheid variable stars, which were not actually done correctly at that time. But when everything got refined and everything got fixed, and since then, when we've actually been able to calibrate to type 1A supernovae, when white dwarfs gain just enough mass to explode in a catastrophic explosion, leaving nothing behind and giving an absolutely beautiful fit curve that we can actually figure out how far away these type 1A supernovae are, we have very accurate estimates, we believe, of how far away some of these galaxies are. And when we measure their redshift, the amount that their light has shifted, it tells us how fast they seem to be moving with respect to us. But all of that motion is not because those galaxies are actually kinetically moving that fast. It's because the space itself is expanding. And so we have been having this discussion over the last few classes, the whole idea of the expanding universe, the measurements taken by astronomers that led astrophysicists to revolutionize our theory of our understanding of the universe, what we call cosmology. And then last Thursday, I had a guest speaker on, Andy Briggs from Spain. And Andy and I are both on Astro Radio together. And he gave a wonderful talk about detecting gravitational waves with LIGO. And when he talked about the gravitational waves, of course, the very first gravitational wave detected was in 2015. And it was this binary black hole merger. And we were able to determine, based on the energy signature, what strength that merger should have had. So then seeing how strong it was when it got to us allows us to estimate the distance. And the distance to this black hole merger was 1.4 billion light years, 440 megaparsecs. And so Andy made a really clever joke. He said, on Earth at that time, 1.4 billion years ago, when these gravitational waves left, the only thing on Earth were single-celled organisms, and it was probably Keith Richards' birthday. Now, that idea of there was nothing on Earth, it was single-celled organisms, because it was only 600 million years ago that multi-celled organisms actually came on Earth. Well, my students just dug into that. That was just a wonderful piece of trivia for them to start talking about. The Keith Richards joke went over their heads. But the idea of these distances relating to times and what was happening on Earth at that time struck them. And then I started thinking that next class, I'm going to be talking exoplanet detection and the Drake equation and the search for life in the universe. That's the way I like ending every unit before the test, is talking about the search for life. So the solar system unit, I end with the solar system search for life. And the cosmology unit, I end with, well, can we travel interstellar? Can we actually go away from our solar system and go anywhere else? And so I started thinking about how am I going to talk to them about the distances to some of these exoplanets? Because some of these groups are actually doing exoplanet transits as their projects. The first group of mine that ever did that was the group that did HAT P16b. And you can see the dip really clearly when the planet passes in front of the sun. Now that star is 740 light years away. The ones the current group are doing are HAT P32b, 950 light years away, and Qatar 1b, which is 609 light years away. 609 light years away. That's the last, 609 years is the last time we had that long of a partial lunar eclipse here. In 609 years ago, we had the era of the Incas was still going on in South America. And we still had the belief that when an eclipse was happening, it was because a jaguar was taking chunks out of the moon. So what are we looking at, and what could they see if they could actually see Earth at this moment in time? Would they see signs of technology? Would they see signs of civilization? Would they actually have any evidence of where we are right now as a people? When you're looking this far away, that's not going to happen. But when the James Webb Space Telescope goes up, one of the systems that is concentrating on is the TRAPPIST system. And the TRAPPIST system has all these beautiful exoplanets, and it's only 39.5 light years away. So when they see any light from the Earth passing in front of the sun, if there is an astronomer sitting at TRAPPIST-D in the start of the Goldilocks zone and looking at Earth and seeing the signature, and they can manage to catch our radio waves, they will see all of us doing the Thriller dance. They'll see us in the early 80s with big shoulders and fluffy hair and, leggings. And that's what they will see, because they will see us as we were 40 years ago. So when we're talking about anything to do with astronomy, it's important to recognize, take some time for us to see the signals that we see. And with that, I thought I'd end with this wonderful video that Scott put together for RASC Montreal Center.
Good.
Thank you all.
Wonderful, wonderful. Well, thank you very much, Karim. I too, I am always interested in how people react to, the effect of, you show them a galaxy, you tell them how far away it's predicted to be due to its redshift and all the rest of that. And then you tell them, look, the photons that were made in those stars through the action of fusion, the atoms crushing there, and they took off all that time ago, plus, the distance of how far it's now moved. Okay. It's this connection that they get because the photons are now hitting the rise, but now they're understanding they're looking so far back into time. Some astronomers also call this fossil light, okay, because it is so old. It really kind of throws them into kind of this different framework, this different position of what they think reality, their everyday reality really is, and so it's it throws them off their base a little bit,
Oh, absolutely. And today's discussion, one of the things that the students really were trying to get their head around was this idea that if somebody in the Whirlpool galaxy is looking at us, or somebody in a very distant galaxy is looking at us, they're seeing us moving away at that speed, and they're seeing us as we were that many millions or billions of light years ago. And so the concept that there's this cosmological principle where every observer in every place in the universe, they see their own local neighborhood kind of like we do, where all the galaxies have evolved to a certain point and there's a certain amount of structure involved. And the further out you look, the more disorganized, the more chaotic things are, the more energetic things are. And that we can't tell if there's an edge or a center to the universe because everybody sees the same thing. They can't get their heads around that because that is such a unique philosophical viewpoint. And we are and talking to them about the fact that every single evolution, whenever we were combated with something that went against our knowledge and we had to change our theories, there were certain things that we tried to latch onto. And one of those was that humans are special. and that the sun is the center of everything. If
Right.
not the Earth, it's the sun. If not the sun, it's got to be the Milky Way galaxy. We got to be the center, because there's got to be something special about us.
Right.
Trying to get them to detach that from the observational evidence, which tells us
Very
we
different.
can't tell if there's anything special about us because we'd never be able to see it. Oh my gosh, metaphysically, that just it some of them they are still digesting it and coming back and talking to me every 20 minutes or so, going, "Sir, my head still hurts. Can we talk more?"
Yeah. At least their minds are open enough to try to continue to understand it. I have had people that absolutely reject it. I mean,
Yes,
we
they
got
shut it down.
that part of it. They were just like, it's almost scary to them, you know, that everything that they know and the way they think about it, okay, is now changed. They know it's different, but trying to wrap their head around it is a big deal. And so that is something that astronomers who do kind of contemplate this stuff, you know, cosmologists who contemplate this stuff, they're special people, I think, you know. So at least they have, in one way, privilege that we can start to try to understand this. We can try to wrap our heads around this kind of thing. But a lot of this is so tantalizing, but at the same time, very disconcerting for some. You know?
Definitely. And just the scale of numbers that you're talking about. I mean, even just within our solar system, when you start talking about 150 million kilometers to the sun, they're sitting there looking at you going, "Wait, what do you mean 150 million? But that's just the Earth, and everything else is much, 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 much further out." The scale boggles their mind.
It boggles their mind.
And that's where it becomes incredibly unique for them to have this experience of trying to find a way to relate to the topic and to the observations that we made, because the observations that we made are still unsettling to a lot of us when we're sitting there looking at it and trying to understand it. So
Absolutely.
The fact that it's unsettling to students is a good thing. It's for them to recognize and to realize that there's a lot out there that we don't. That quote that you put forward for today was amazing. The idea that really the things that we now are understanding, we can't understand why people couldn't understand them 30, 50, 600 years ago. It seems so obvious to now. I told my students about the Olbers paradox, this idea that if there's stars everywhere, how come the sky isn't just bright white? And that at that time, we didn't understand that the intensity of light drops off as 1/r² as you move away from these objects, so that even though there's stars and galaxies everywhere you look,
light would continue to fill up the entire sky, right?
Exactly. It dissipates out in intensity. And that seems natural to us now because we've grown up knowing that all of these force laws are all 1/r², and we take it for granted. But if you ever stop to think about it, you can understand why it wasn't understood until somebody quantized it. And so somebody made a model that says, look, this makes sense now. So what don't we understand now that in 60 years, people will look back at us and go, how could you not figure this out? Like, you don't deserve those honorary doctorates. Let's find out who this David Levy person is who gave you honorary doctorates. You don't deserve them.
No, he doesn't. But could I add something to what you said,
Sure.
Karim? Actually, one of the first people to explain Olbers' paradox was none other than Edgar Allan Poe, who wrote a scientific paper about it. And I think he had the right explanation all the way back then, like the early part of the 20th century. And this is one of the
Poe
big
was
things.
brilliant. Absolutely brilliant.
I am curious though, Karim, when you're working with your students and you take them to this point where their brains are hurting, they are now in a spot intellectually or maybe philosophically or something where they're in a very uncomfortable position, okay? You've taken them to no man's land, okay? How important is that to learning and making the leaps in learning at the, you know, in a young adult's life?
Incredibly important. The one thing that you need to make sure, especially when you're talking about a field that they might be interested in down the road, is that they recognize that there are open questions and that they recognize that there are approaches for everyone. Somebody who's just interested in the mechanism can work in aerospace engineering or in optical design. Somebody who's interested in observational data can work on data analysis for telescopes or for working through vibrational analysis for satellites. Somebody who's really interested in the deep philosophical anchorings can work in theoretical astrophysics and cosmology. But recognizing that there are these open questions, and there always have been, no matter how we try to refine our theories, open questions remain. And that's why we keep pushing the boundaries of knowledge. That's one of the goals of especially post-secondary education, but I think even secondary education, is you want students to realize all the answers are not in that textbook you hold in your hand. All the answers are not sitting there on Google. You have to actually search for answers, and you may not always find them. And that's one of the most enlightening things for a student, is when they come up with an answer that's wrong, but they did the process right, and they realized that, okay, this was not the way to get this answer. That acknowledgement that you can't always pick the right path to find a solution or to find an answer the first time is something that not every student is exposed to. And then it causes them problems down the road. When they come up against a hurdle, they feel catastrophic failure. They feel this depression that, oh my God, I'm not good enough. This isn't my field. They don't understand that this happens to every scientist. This happens to every academic. This happens to everybody in every field. You fail, you make mistakes, you don't understand something, and you have to go and learn more. Right. And so the one thing that I don't do is I don't let that be the last class, which is why next class I'm going to tie them back to exoplanet search and something a little bit more tangible, because I tried my very first time I taught the course to end with astrophysics, and it was just, for them, it was too open. So then I actually called them in during the exam period when exams were done. Anybody who wanted to come in, I'll do an optional 45 minutes, and we're going to talk about some of the practical things you can do next year if you want to keep looking up at the night sky. Every single student showed up.
Awesome.
This was right before Christmas. So they all wanted something tangible to walk away with.
Right. Very interesting. Okay. Well, thank you so much, Karim. That's awesome.
My pleasure.
Thank you so much. Okay. Up next is Adrian Bradley. Adrian does incredibly beautiful and sensitive skyscapes with his work of photographing the Milky Way, aurora, comets, asteroid, or meteor falls, and putting in context our world in there, and the way that he describes it, the humanity of it. So, Adrian, I'm going to turn it over to you, man.
All right. I wanted to piggyback a comment that I thought of just as my new lowbrow brother in arms, Karim, finished the statement. Real important statement about science. And you may go about a process, you may not get the right result, but it's all a part of how science works. And I think that's a real important message for those of us that are trying to promote scientific topics like astronomy. We've watched our world go into a world of I know everything and this is the way it is. We've watched our world as people have pushed agendas and pushed what most I think realize is a lie. I'm just going to say it. The election and everything around that. We're seeing this, and as science-minded people, we shake our heads and go, how did it come to this where we're not willing to try, we're not willing to get out there, we're willing to look on Google, and the University of Google is giving a lot of folks answers. Our mission, and part of the reason that I do these nightscapes, it's just part of the mission of saying there's a reality out here that's beyond your mind and beyond what you're seeing on TV or YouTube or other forms of social media. And it's my hope that programs like this, reach a lot of you, and that those of you that are on watching it live are sharing with others and just say, hey, there's something out there besides ourselves. And I think it's the great humility that if you don't learn it from religion, you can relearn it from studying the universe and realizing we're just a small part of it. And it's
Well
a
said,
big reason.
Adrian. Well said.
Yes, big reason I do my photography. And I'm sharing my screen, and this is an image that I took very recently, and I didn't get the results I was looking for. The Milky Way was very faint. These were some tough conditions. There were cars on the driving by me, and this is faint Milky Way, and the moon is rising behind me. I was able to turn around and see the moon over the horizon as I was taking this photo. Most probably wouldn't try for it because, well, why try to shoot the Milky Way when there's a bright moon out? But it doesn't stop me from trying to create a picture of it. And it doesn't stop me from seeing if I can get a part of the Milky Way here, because I did it once before. A couple of years ago, the core of the Milky Way was visible near this receding moon, and I got a pretty good shot on it. And this was before knowing how to noise reduce, which I would have done some noise reduction here. But I was just happy. There's M8 and M22's this dot over here. I was able to get a Milky Way shot with the moon. And M22's this dot over here. I was able to get a Milky Way. Oh, I'm hearing you. I'm hearing a feedback on you, Scott. Something was coming.
Oh, okay.
But that's okay. So we don't always shoot in pristine conditions, and that includes the effects of light pollution. And I'm going to get to time in a minute. I wanted to talk about that, our main topic. But another thing that I learned when I do night photography, Milky Way's behind here somewhere. And these clouds are lit in a between Bortle 4, Bortle 5 zone. Milky Way's behind here somewhere. You can hardly see it. When you go to a dark site, you not only see the Milky Way, but the bottom of the clouds are dark black. So those of you that haven't been to a dark sky site, there's a huge difference between what you may think is dark. A lot of people think that this location, which was Lake Hudson Dark Sky Park, is dark. But then true darkness, things change. And you not only is the Milky Way just shine through, the bottoms of the clouds are black. So for those of you that haven't visited a dark sky park yet, I highly recommend it. So I want to move on to the lunar eclipse because I did get a chance to take some shots of it. And I'm going to pick up where Karim left off. When the clouds covered his area, I was in someone's backyard where the skies were clear. They cleared up in time for us to see the entire lunar eclipse. So this is one of the images. This is pretty much about where Karim lost the eclipse due to the clouds, but I kept on shooting. I ended up taking a couple shots here. We're getting closer, and you can see Tycho, the crater here. Most of these are either handheld or on a tripod. There's enough of the moon to be bright enough to be able to take a picture hand holding it using image stabilization. Then it got to the point where it was around 97%, and that's the image that you've seen. There's 3 stars here, 4 actually, that I can see. Had I done a bit better exposure, we might have seen more stars around this 97% eclipse moon. This brightness here was just enough to make it a little more difficult to image. However, I did a couple composites where I took an exposure in the backyard. There are the Pleiades, the Hyades, Taurus, and Orion. You might barely be able to faintly see some nebulosity over here. It's called Lambda Orionis, and I wanted to rename it the Afro of Orion, but more on that later. But when the moon goes even 97% covered, the stars come out. On a full lunar eclipse, the stars you get just that much more brightness. So an image that I'm taking here, which is an interesting take on time. You have the eclipsed moon and you have the Pleiades star cluster that are close to each other in sight. This particular eclipse moon was near the Pleiades. I forget how many degrees. I mean, I would say 7, I think, with this. This was taken with a 135 millimeter camera on a full frame sensor. For those that are out there that know what that means, it perfectly framed the Pleiades and the moon together. There are some other very beautiful images of this. Some of them are may or may not be anatomically correct, depends on where they put the moon, but there are some gorgeous images with a fully exposed Pleiades with the nebulosity and its void here, and you've got the eclipse moon. Now the interesting thing is this moon is 238,855 miles away. And the Pleiades, that light reached us after 424 years, 424 light years away. So when contemplating time, looking at this image, we're seeing what appears to be something that's happening at the same time. The Pleiades light is reaching us, the light from what little light we have from the moon, and then the shadow, the red shift of the Earth, all the other light scattered out and shining red on this moon. It's hitting us at the same time, but different time scales. I mean, light years versus the moon. So when the moon changes again, we see it within a couple of seconds. Anything happens, any of these stars were to explode, we wouldn't know for 424 years if it happened at that instant. So it's just something interesting. And then all the stars that are in here, if they went out today, these stars have various distances from them. If we were plate solving for them, we would find out when they would disappear or change would be a matter of the number of light years that they're away from us. So it's very interesting when you think about the differences in the time scales. As the shadow, the moon, comes back, that it was setting, it was heading towards our horizon. And this was one of the shots I decided to take. I took a few of them. This is one that turned out pretty good. Once again, handheld. And you see the curvature of the Earth as it's letting go of the moon. And then finally, as the sun is beginning to come up on twilight, I took this picture of the fully freed full moon. I know one of the answers, I believe, for Astronomical League is whenever the moon happens to be in the ecliptic, when it lines up with the solar system ecliptic, it can be eclipsed, and you can have lunar and solar eclipses. This is a similar location to where Mars was sitting. I've got that image somewhere around. I think I have it somewhere. Mars is not far. I'll just click on this one again. When Mars was close to the Pleiades, Mars was somewhere around where the moon is. And I wonder if just the moon being along the line of the ecliptic is what made that a possibility, that it may end up in what is almost the same place that Mars and some of the other planets end up in relation to the Pleiades. So I found that bit of symmetry interesting. And let's see, finally, we talk about time. Couple of images that don't have anything to do with space, but it looks like we're bending time, but I think that was a function of my camera. These gentlemen don't even realize this ball's been fouled off yet. His glove is staying there. I have another image with the foul ball off this way. How quickly professionals swing the bat. An instant like this, we see it instantly if we're sitting in the stadium. However, we still don't know if anything happens here. We're not going to see it for 424 years. Betelgeuse, we're not going to see whether or not it explodes. Sometimes we get lucky and we can capture an instant where right before a bird enters the water after prey, this instant is so quick, you blink and you miss it. But when you're talking with space, you blink some more, you come back the next day and it looks the same. And then somewhere over here, Betelgeuse, it could have blown up in an instant, but we don't know. That's the difference between what we see with our own eyes on Earth versus what we see in space. It can be a very remarkable thing to realize that, I guess, relativity, time, how vast the universe is that the same instant someone can hit a foul ball and we don't notice it until we see the ball all the way back to the backstop. Something could happen in one of these stars in that same instant, but we wouldn't see it for years and years. So that's something to contemplate. And I'm going to end this segment with my bid to make Lambda Orionis here, call it Orion's Afro. I have plenty of pictures of Orion's Afro. Here's Orion's Afro and the zodiacal light.
Well, you heard David Levy. You don't need permission from the IAU or anybody. You just make it and publish it. So,
well, that's what I'm going to have to do. All these pictures, I'm going to publish it and I'm going to draw a line and say, this is Lambda Orionis, AKA the Afro of Orion. And Barnard's Loop, I'm going to call it a sash. I'm still going to call this the rosette. And I think this was a camera artifact. I'm not sure this is actually anything, but and I'm going to still call this a beautiful scene in one of my favorite places, the image. Final note, those of you that are using modified cameras, here's the original shot of my modified camera with all of the pink. Yes, I could use a flat for those of you experienced astrophotographers. I'm working on it. But if you change your white balance to around 27, mine goes down to around 2700 Kelvin, and then move the tint more into the green area, you get what looks more like a true color image. So those of you that are thinking of modifying your camera so you can take photos like this and get all the hydrogen alpha data in your shots, those are some of the things you'll have to consider. So Scott, I think I ran over time a bit, but I enjoy talking about the various things I like to image. Outreach is something I love doing. And so it's just part of what I do to try and share my own understanding of the universe and how how it affects me. So hopefully those watching got something out of it. And that's it. I'm turning it back to you, Scott.
up next is Molly Wakeling. She is imaging live from her backyard. She's not able to come on as frequently as she has in the past, but she's very, very busy studying and getting things done in this time in her life. And so
Scott, do you mind if I say something first for a moment?
Oh, of course, no problem.
Yeah, go ahead. I'm still trying to get my target in the right spot.
Okay, sorry, Molly, but I know that I really should discuss this with you in advance, but it's pretty harmless. This Sunday, we are going to have a group getting together over Zoom, a group of junior astronomers. We're hoping to get a group of people aged, say, 10 to 17 or so on Zoom. It's going to be at 10. It'll be starting at 3 o'clock my time, which is 5 o'clock Eastern time, 6 o'clock Scotty's time. I was wondering, Scott, if I were to send you a link to that meeting this Sunday, and if people in the audience tonight would like to attend, they write to you and you could forward them that link. Would that be
Sure.
acceptable to you?
Oh, of course it would. Yes, and so if you are interested in attending, you will just send a email to Explore Alliance at explorescientific.com. I'll put that right down here. And this is for the Sunday. What is the event called?
It's actually the Junior Astronomical League. It is, I know I'm jumping the gun here, but we're trying to get it's a group of people. It started in Denver. It actually started when I was a youngster in 1963. And I am trying desperately to preserve the magic that attracts young people to astronomy. It attracted me to astronomy,
Yep.
and I never lost that magic. But so many of us do as we get older and we get to adults. Remember that famous Peter, Paul, and Mary song, Puff the Magic Dragon?
Yes.
The final words, the final verse, a dragon lives forever, but not so girls and boys. I'm trying desperately to preserve that magic that little girls and little boys, or not so little boys and girls, can keep in astronomy. We'll be meeting on Sunday afternoon, and we'd like to invite you to come if you're interested. I'll
Yeah.
send you the link, Scott.
Okay. Well, that's a worthwhile interruption. No problem.
Okay.
David, thank you so much, man. Thank you. Okay. So Molly Wakeling is with us. Molly, are you, how is it from your side?
Let's see, let me just move this to where I think, which one of these I think it is based on looking at stuff. Yeah, okay. So I love the topic, this whole topic of tonight, of the fact that when we look out in space, we're looking back in time and what that means, and just how staggeringly big the universe is, and how far away we can see things even from our little itty bitty ground-based telescopes sometimes. So it's been on my list for a while to image a quasar, but I haven't gotten to it quite yet. They don't really make for pretty images because they just look like stars, which is why quasar is short for quasi-stellar object. But I decided that for tonight, it would be good if I could maybe get one in my live view. So I went hunting on Astrobin for one that was of a bright enough magnitude that I can probably catch in some 5-minute exposures stacked and stretched on my 8-inch Schmidt-Cassegrain, which is not the right. There we go. That one. Had the wrong one there. Which is currently out in my backyard here in Dayton, Ohio. And the moon hasn't risen yet. So the sky quality meter is reading, I think it was reading 18.97 last I checked, which is not amazing, but is about, it gets about to 19.10 at the best around here. A good dark sky sight's like 21 or something like that. So not real dark here.
Yeah,
but
21 is perfect, I think.
It's pretty
for
dark.
Yeah.
Earth. Yeah.
Yeah. So it might sound like a small distance away, but the difference between 19 and 20 on the dark sky scale is pretty vast. So 18.97 for around here is not bad. And the moon will be up after a while, making it much brighter. But anyway, so I went hunting down a quasar that I could possibly reach with my 8-inch. And there is one, and also had to be something that wasn't blocked by my trees, or there's a lot of them that are in like Ursa Major or in a lot of the constellations that are up in the springtime that have lots of galaxies, which makes sense. But of course, it's not the springtime yet. So, but I did manage to find one that is in, I think it's in Draco, if I recall. and it is has the clever name of KUV 81217 plus 6419. That number comes from its coordinates in RA and DEC of a sort. So in order to figure out which thing it was in here, ordinarily I would go and upload this in plate solve and stuff like that. But for lack of time, because I just got home from work a little while ago, or from school, I found a picture on Astrobin of somebody else that took it and just kind of triangulated the coordinates of the stars, basically star hopping, but on a picture. And I think this is it. It's a little hard to tell because my picture is inverted from theirs, and some of the stars are brighter in theirs and stuff like that. But there's the PK 94 plus 27.1. There's supposed to be a planetary nebula here, but it's a really, really dim planetary nebula. So I'm not picking it up right now. Actually, you cannot see where my mouse is because I'm pointing at the wrong screen. Yeah, so there's supposed to be a planetary nebula like here. But yeah, I can't see here, but I think it's one of these three stars. I think it's this one. It's a magnitude 14.1 quasar, and it is 3.1 billion light years away. If I'm going back and double checking my numbers here. Yeah, 3.1 billion light years away. So that's with a B. So like we have galaxies that we can see pretty decently in the telescope, like the Whirlpool galaxy that's 25 million light years away, and like M33, which is 3 million light years away. So this is it's like 3 orders of magnitude farther away than it's so far away, guys.
Yes.
a thousand million light years away.
And moving further away all the time. So
yeah.
So you're saying it's further than from here to Los Angeles?
A little bit, yeah. Yeah, so we're seeing quasars are ridiculously bright galaxies that are like ordinarily galaxies that are 3 billion light years away. You would need like the Hubble Space Telescope to be able to observe, and the Hubble Space Telescope does observe galaxies that are even farther away than that. But with amateur gear, you can actually see some quasars because they're so much brighter than galaxies that are at that same distance because of their very luminous active galactic nuclei. And so that light's been traveling, well, it's not even necessarily been traveling for 3 billion years because space has been stretching in that time. So it's actually been traveling for longer than that. Right. If I had time, I would have done the math on that, but just got back, so I didn't get to do the math on that. And yeah, it's so cool to be able to, with amateur equipment, to be able to, and actually there are some quasars. There's one that's like magnitude 12. That's, I can't remember where it's at, but I've seen it in like a big Dobsonia at the Texas Star Party. There are some of these that you can see visually, which is even cooler because that light like was emitted like before the Earth was formed in some cases, and here it is getting absorbed into our retina in the modern day. So it's just crazy.
Yes. I think the first quasar I saw, Molly, through I had a 13.1 inch Dob, was quasar 3C273.
Oh yeah, yeah.
And to know, I mean, that's 3 point whatever billion light years away, and it looked like a beautiful turquoise blue star, And I remember telling a friend of mine that was an astronomer at the 200 inch at Palomar, he says, what's interesting? He says, they look like that through the 200 inch as well. He said, they're so far away, they're just pinpoints of light,
Yeah.
So really cool stuff. But, well, that's awesome. Thank you, Molly, for coming on.
Yeah, you're welcome. And my other telescope is still cooling the camera, so I haven't started running it yet. So I might have something else to show a little later.
All right.
If you want to pop back over
later. That's great.
What target are you going to shoot at?
Yeah, so well, so on this scope that I'm looking at the quasar with now, as soon as we move on to the next speaker, I'm going to turn the sequence back on, and I'm imaging the Pelican Nebula and
cool.
the oh gosh, it just left my brain. The heart, the heart of the heart. So the the core of the heart nebula. And I'm imaging those in Hubbell palette because I just recently received a full set of test filters from Optolong with the new 3 nanometer narrowband filters that they're going to be offering soon. So I'm going to test those out and write up an article about it. And I'm hoping that they're really good because I might buy their sulfur filter because the chroma filter to complete my set is really expensive right now.
Super expensive, yeah.
The Optolong filters are a lot more reasonably priced right now. So we'll see. And then on my Takahashi, I am imaging on my other rig, Sharpless 2 115, which is a just like an H2 region, a cool large nebula, the Flame in the Horsehead Nebula, and IC 342, which is actually a pretty large galaxy from our perspective, but it's in the plane of the Milky Way, so it's really hard to see because it's heavily extincted by the dust that's in the plane of the Milky Way. So it kind of has a very yellowish color.
Isn't that Sharpless object near the 37 cluster? Is that in Orion that you're shooting?
No, this one's not in Orion. It comes up a little earlier. Let me double check.
Okay.
Yeah,
there was a difference.
It's in Cygnus, like a lot of these guys are. And yeah, it's just a cool looking sort of nebula region that is a really good fit for. I've got a one of those duo band narrowband filters on here with my color camera. That is the Optolong L Extreme. And that one I actually own. And yeah, it puts out some nice nebula images, especially from in here in the city.
Okay, yeah, it's cool and interesting about the Pelican. I'd done some wide field with the North American and the Pelican Nebula. The Pelican was always just this blob. After seeing a Hubbell image of it, and then going back to some of my images, I finally saw the shape of the Pelican, and I can
little antennae.
Yeah, and I can best describe it as it actually kind of looks like a football mascot type of pelican with the big beak coming out, the eye, kind of a cavity within the nebula itself. So it was just sort of an aha moment when and then I went back and I said, yeah, there's the shape of it right there. Yeah. In my own little crummy little image. But it's like, yeah, that's now I see why they call it the Pelican.
It's got a really cool, like in narrowband, in hydrogen especially, it yields a lot of very fine detail. And it's got these two, what I always kind of imagine as antennae kind of sticking out of it. And even on amateur scopes, you can resolve a lot of detail in the hydrogen alpha channel on that. And I've imaged it before in hydrogen and oxygen. And I wasn't real happy with the way that it ended up coming out. My hydrogen image of it by itself was really gorgeous. Like a black and white starless monochrome image. But with the Hubbell palette, it looks really cool in Hubbell palette. So we're looking forward to doing some Hubbell palette processing on that.
We're looking forward to it. After your so many hours of integration, how many hours you plan to put on it?
Probably like 20 or so.
Yeah, you're gonna
20 to 30.
Yeah, so we'll see you in January when you finally process this image.
It's gonna be a while. Yeah,
looking forward to it.
You got to get a lot of hours when you're under Bortle 7 skies. So.
Yeah, but that's that's the way it is. You've got the equipment to do it. So
I might be able to get away with less, maybe like 10 or 15, because these are very narrow band filters, only 3 nanometers. So we'll see how long my patience holds out for.
Well, we all know a Struble is 30 hours, so if you make it to a Struble, there's a special door prize or something.
Yeah, I've only gotten, I think, 2 images over 30 hours before. One was an incredible dumbbell image that I made in hydrogen and oxygen that I am super, super proud of. So.
All right, Scott, I don't have any
Yeah.
more questions.
All right, sounds good. Okay, so up next is Mike Weasner. Mike is a champion of dark skies. He is an enthusiast of astrophotography and astronomy, amateur astronomy of all different kinds. He is fascinated with the night sky, and he is working closely with us right now to put together the next Arizona Dark Sky Star Party that will feature David Levy and a number of speakers. Mike Weasner lives out near Oracle, Arizona, where it's dark, where you can see the Gangenschein and the zodiacal light, and of course the Milky Way. But we're going to talk about dark skies in general and what it's like out there near his home. It's all yours, Mike.
Thank you, Scott. Appreciate that. Yeah, we got dark skies and they're really dark tonight because it's cloudy. So
Well, make it even darker.
even darker, and the moon hasn't quite come up yet either. So I'm going to share my screen. I've got a few little slides I want to show. Let's see if I can do the right one here. It looks like it. Hopefully that's it. All right. So we're going to talk about Oracle State Park, which isn't here in Oracle, Arizona in the United States, and it's an international dark sky park. So along the way, we're going to talk about light pollution and some other things, and then we'll talk about the park. This picture was taken a few years ago, I think it was 2015, from the park, showing the Milky Way, obviously. That little orange glow that you see at the bottom of the picture is not sky glow. It's not light pollution from a city. It's actually smoke and fires that were up in the mountains about 100 miles east of Oracle at that time.
Wow.
So added a little bit of uniqueness to this picture. I did a video of the Milky Way rising, and you can see the flames kind of popping up and down, the smoke blowing along there at the bottom, which is kind of an interesting video, unfortunately. But no problems right now with any fires out here. So for those of you who don't know me, I thought I'd take a few seconds and just kind of introduce myself a little bit more than what Scott said. I haven't been on a Global Star Party for several months, I guess, although I've been on some other Explore Alliance live events, and I've got one coming up with Tyler Bowman, I guess, in a week or so, hopefully.
Yay.
So we'll see you all again on that one. Anyway, so who am I? Well, I've got a degree in astrophysics from Indiana University many decades ago. And a little bit of look back time. I've been an amateur astronomer for many decades. The picture there on the left was Easter Sunday morning, 1862, with my brand new Christmas present from 61 from my mother, an Edmund Scientific 3-inch Newtonian telescope.
Yep.
And,
Mike, you're still on your first slide, I think, from Oracle State Park.
That's weird because I'm showing the thing again. Well, let me unshare if I can.
Yeah, I think you're showing, we're seeing you not in presentation mode. So if you have a second screen, you might have grabbed the wrong screen.
Oh, okay. Well, let me see if I can get out of sharing here. Stop
Yeah, that's
share.
that image you just had was the one that I think you were
Yeah,
talking
that's what you
about.
were talking about.
Yeah, but go ahead. I think, yeah, try it again.
So
There
you
you go.
seeing that one right there?
Yeah.
So we're hit the present.
Yeah.
So we're seeing your like the PowerPoint, not the slides full screen.
Oh, okay.
Do you have two screens?
No, I just have one. That's what's kind of bugging me. Let me try one more time.
All right.
If not, we'll do it the other way.
Yeah, we'll just click the each.
Yeah.
So which screen?
That's what
there
we
we
are
go.
looking for. Yep.
Alrighty. Okay.
Now
All
we're
right.
good.
Now we're good. Thank you.
Yeah.
Thanks for catching that. So anyway, the picture on the right is obviously the same telescope, same person, and actually the same house that I grew up in, taken in 2016. So a little bit more flab on the belly, but other than that, the telescope's still the same. I'm a former Air Force A-70 fighter pilot and T-38 instructor pilot. I was a former manager on the Air Force's space shuttle program back in the 1980s, senior manager at a large aerospace company, and I retired in 2007. And we purchased our land here in Oracle in 2004. We moved to Oracle in 2009, and I have my own small astronomical observatory, about 120 feet from where I'm sitting right now.
Yeah, and you kind of skipped over a really incredible book called The Mighty ETX.
Oh yeah, yes, indeed. As Scott mentioned, I'm somewhat famous for starting a website back in 1996 that is actually still going. Weasner's Mighty ETX website to kind of highlight the capabilities of the Meade ETX line of telescopes, and I still have all those telescopes too. And I was the chair of the Oracle Dark Skies Committee from 2014 to 2018. And we'll talk a little bit more about that in a bit. So what is light pollution? Just really quick, we'll talk about that. Well, so this picture is a recently declassified satellite photograph showing the United States 500,000 years ago. And as you can see or not see, there's no lights coming up from the United States. Unfortunately, a more
Utopia.
recently declassified. Is that right?
What?
It's recently declassified.
Yeah, recently declassified satellite.
Very nice.
500,000 years ago. I won't tell you the source.
Okay.
Anyway, here we go. So here's obviously what the United States looks like now with gobs of light pollution. Not good.
Subtle difference there.
Yeah, a bit of a difference. So light pollution is basically any lighting that's aimed horizontally or it's aimed upward. They're typically unshielded lights, so the bulbs are visible. They're brighter than they need to be. They illuminate with a daytime color temperature, and or they shine beyond where and when they're needed. So there's ways to obviously address all those concerns. Some other terms that are used to describe such lighting are, there we go, light nuisance and light trespass. That's when your neighbor's lights or your business light across the street is shining into your house or into your backyard where you want to do your imaging, or you're out there just as wanting to enjoy the night sky with your children. So light nuisance and light trespass are a couple of terms that get applied to that. Artificial light at night is basically covering any sort of lighting at night. Eliminating light pollution does not mean no light. That's kind of a common misconception by the general public. We do not mean no light. What we mean is, boy, my keys aren't working here. Here we go. It does mean to be smart when using outdoor lighting. Light pollution certainly impacts the science of astronomy. As us, as amateur astronomers, we know too well. There's appreciating the night sky by the general public who know that the night sky is worth appreciating. And there's, thousands of years of cultural heritage all surrounding what's visible in the night sky. Astronomy is an important business here in Arizona. These numbers are from, I think, 2007, not adjusted for inflation, but it's still a big business here in Arizona, $300 million a year and $2 billion worth of facilities. And so we do want to protect the night skies here, certainly here in Arizona. But there's many serious issues and costly impacts from this pervasive light pollution that go well beyond just science. Human health, wildlife impacts, energy costs and waste, and of course, climate change. This was something that I came up with just a few months ago from watching some commercials on the Phoenix TV stations. We've all heard that spending money on space research, sending people up into space, that's all money that could be better spent here on Earth. For example, feeding the homeless and the needy families. Well, there's a company up in organization up in Phoenix and they do this Summer of a Million Meals. And they claim that they can turn $1 into 5 meals. So light pollution energy costs are $7 billion annually in the United States alone. So that's 35 billion meals that could be provided to the homeless and needy every year if our governments and businesses and citizens would just stop wasting light. That's a lot of meals.
That's a lot of meals.
If you add in healthcare costs of all the ailments that are caused or contributed to by light pollution, that number of meals increases even more. And of course, worldwide, this adds up to hundreds of billions of meals annually. So if you tell people that, you know, some of them may not care about all the health issues, the various cancers, blood pressure problem, Parkinson's, because it's not affecting them. But they say, yeah, we're wasting all this money on space research. You tell them about billions of meals are being sent up into space. That might get their attention.
Yeah.
So the International Dark Sky Association, which is headquartered down in Tucson, about an hour from where I am, promotes this win-win solution to allow people to appreciate the dark star-filled skies while enjoying the benefits of responsible outdoor lighting. The International Dark Sky Places Conservation Program recognizes and promotes excellent stewardship of the night sky. They have several categories of designations. There's communities, there's parks, reserves, sanctuaries, and urban night sky places. These designations cover places of different sizes, of different types of recreation, different types of preservation activities that they do. Each designation has its own set of guidelines, which are available at darksky.org/IDSP, and you can see the cover of the Dark Sky Park program guidelines. And there's right now, as of today, there are 180 places designated worldwide since 2001. And they expect that they're probably going to hit 200 here very quickly. Oregon State Park was designated as the first international dark sky park to be an IDA International Dark Sky Park in 2014. And here you can see the gate sign that we proudly hung the International Dark Sky Park sign underneath that. And as Scott said, it's going to be the site of the 2022 David H. Levy, Arizona Dark Sky Star Party and Astrophotography Workshops. So we're really thrilled about that up here in Oracle. So welcome to Oracle State Park. This is one of the signs that will greet you up by the parking lot. And you notice there that the International Dark Sky Park is highlighted there right in the center. Oracle State Park's a 4,000-acre wildlife refuge here in the northern foothills of the Catalina Mountains, just north of Tucson. The park offers day use picnic areas and over 15 miles of trails that are used by hikers, mountain bikers, and equestrians. And it's known, very famous for those trails. A section of the Arizona Trail actually crosses through the park. There is a remote area that's available for stargazers when the park is closed. And I was out there a couple of weeks ago doing some sky quality readings for Scott. And sure enough, there were like 3 cars sitting out there looking up in the night sky. People looking up in the night sky. So here's a kind of a scenic view from the park, showing those mountains about 100 miles to the east of the park, the Galero Mountains. And this is where the fires were that I mentioned earlier. The fires were out there in the mountains. One of the neat things they do at the park is they do live music events, and they will place musicians that you see right there in the center of the picture along the trails. And as people are hiking the trails, they will hear music as they go along. And then when they get back to the main complex, the ranch house and the parking lot area, shortly after sunset, we've got telescopes set up for them for our star parties. Very, very popular type of events. So, you know, Scott was mentioning about the zodiacal light, as I call it, or zodiacal light, as other people call it. To me, it's the zodiac, so it must be zodiacal light. Anyway, so here was a picture at the park during one of our star parties, and right here you can see the cone of the zodiacal light coming up in the western sky. And this was Venus, I think, up in the sky at that time. So yes, indeed, you know, we do have nice dark skies here at Oracle State Park, and because you can see the zodiacal light. This next picture was actually taken just outside of my observatory here, and I'm about 4 miles west of Oracle State Park. So, you know, the sky quality is still pretty much the same. And I'm showing Gegenschein, and that's this little bright area right here in the middle. Here's the Andromeda Galaxy, the double cluster, Pleiades, and the Hyades. So just a nice night sky rendition, but Gegenschein, very visible from this location. Shows you just how dark our skies can be here. So I hope to see many of you at Oracle State Park for the Arizona Dark Sky Star Party next September. We're going to, like Scott said, we're going to have some really great speakers, and you're going to have a really great time at a nice dark sky location. So contacts International Dark Sky Association at darksky.org, Oracle State Parks at Arizona State or azstateparks.com/Oracle, and my observatory Cassiopeia at weasner.com/CO. So over back to you, Scott. Any questions?
All right. Thank you so much, Mike. That's great. We're going to do a 10-minute break here. And so, grab a sandwich or a cup of coffee or whatever you'd like, stretch your legs, and we'll be back with more astronomers, coming back with Tyler Bowman, Jerry Hubbell, Annie Scarborough, all from Explore Scientific and here in Arkansas. Marcello Souza will be in from Brazil. And then we've got our contingent from Argentina. So stay tuned.
The Argentinians.
Yes.
Excellent presentation, Mike. Hopefully my image of the clouds with light pollution under them versus clouds at a dark sky site. I found that interesting. I had taken the picture of the clouds because I was trying to shoot at the Milky Way there, and then the clouds just showed up right at the time I got set up.
Right.
So in frustration, I just snapped a photo. Little did I know that I would be, that photo would then be useful for, I guess, showing some differences between what a dark sky looks like and a sky that's not far from cities, Portal 4 versus Portal 1.
Right. Right.
And now I'm intrigued. You're running around a similar time frame to the Okie Tech Star Party, and now I'm torn because I'd like to visit Arizona and see Dr. David Levy, who Maxi and Molly, you all missed out. We're all honorary doctorates thanks to Dr. Levy. He handed them all out to everybody that was here for the early part. Here's the irony. My wife is a real doctorate. She got her doctorate in education this past year. I think I'm supposed to know the date, but remembering things is not my strong point. But it took her quite some time, a number of years, to finally get.
Oops. Uh-oh.
Uh-oh.
He got praise.
At
But
least it's not like
now
a
you all have frozen. So there was
He's frozen again, but he's in a cool
Yeah.
pose. He's in a cool
Oh, Adrian, the problem seems to be on your end.
Oh, he's
so-
back.
Yeah, my internet connection is unstable. It says it. So
I think everybody has internet issues really today.
Yeah, when I woke up this morning, I found out that I had absolutely no internet connectivity from any of the Ethernet connected devices or the Wi-Fi connected devices.
Whoops.
I actually, what we have here, because it's a rural area, there's no cable TV, there's no fiber. It used to be on HughesNet up through a satellite, but a year ago, we switched over to using an LTE router from AT&T.
Mhm.
And the cell tower is about a mile outside my window. So we have good, strong signal. I get up this morning, there's nothing on the network, but the phone still had 5G and LTE. So rebooted the router, and fortunately it all came back. But I don't know what happened, but because it had never just totally died before. In fact, I couldn't even talk to the router from my computer through Ethernet, just because
These
the lights are
things
still all
just-
blinking on it, but absolutely
things
no
just
connectivity.
randomly
I used the
do-
power button to try to turn it off, but not turn off.
that can all be caused by a squirrel that decides to chew through the line.
Or a
Yeah,
cosmic
yeah.
ray that hit the right bit and flipped it.
Yeah,
That's what I always
I
blame
think
it
the
on cosmic.
squirrel's probably more likely. The cosmic ray is cooler though. We have had some more solar activity, so we might get one of those. That would be fun to watch, or not if chaos were to ensue. But
Yeah.
Yeah, at least we would know what's going on. What I was saying before my internet rudely interrupted me is that you were trying to get your PhD, weren't you, Molly? Aren't you? You're
Yes.
pursuing it now, right?
Yeah.
So you won't need any stinking honorary doctorate from Dr. Levy. You'll have your very own.
We should get certificates, from Dr.
Yeah.
Levy. I mean, he's a real doctor. So
Yeah, I
we
do.
should get
Yeah, I
some
do know.
honorary, PhD certificates signed by Dr. David H. Levy.
I'll ask him to get right on that.
I'll be sure to show that to my advisor.
Yeah, you're already an honorary doctorate.
Yeah. Are you sure I need to keep taking this class? I mean,
You could try. Speaking of honorary doctors, Dr. Maxi is in the building. How are you doing?
Well, I'm not actually a doctor.
Neither am I, but
No.
I guess I have to carry on bestowing the honorary doctorates.
Yeah.
Except Molly, you're trying to get a real one, so I can't, you can't shortcut your process. Tyler, you get one. Annie gets one.
I think we are pseudo doctors.
Yeah.
Pseudo is previously to say fake, so mostly. Well, I'm so tonight because I came back from home from my work, and my head was really heavy. And I take
ingested?
No. I take a ibuprofen to.
Okay.
I felt like I have some kind of fever, so
okay.
I take a shower. I go a little to the bed, but I didn't know if I'm going to connect. But I say now I have to connect because my mind has to continue. And well, if I feel bad again, I'm going to bed again. But I saw a picture from a person from Paraguay that yesterday took pictures of the quartet of Grus, the four galaxies, and it's passing by right now a comet calling. Let me find it. The name is
Leonard.
No, Leonard. We can see it. Yes,
okay,
from here. It's the
cool picture, Molly.
Wow. It's the 90P Borelli. It's passing by really near through the galaxies, and I don't know if no, it's really
yeah, it's not coming up for a while.
It's too much shine, but I thought, oh, this is a really good opportunity because I have it here above my head, but I'm really tired. And also my wife took off the computer and I couldn't do anything. So okay, maybe next time it will be happening again sometime. So
well,
you gotta take care of yourself.
That's right, Maxi. You gotta take it easy on yourself. I understand you needing a diversion, so you're not thinking about how maybe bad you feel, but also you have to take care of yourself so you feel better.
Yeah. So I really, when I remember when I spent time outside in my backyard in winter, I was focused on taking pictures and see how it's going the guiding and everything. And I forgot that I had to care about the freezing, also I didn't eat, I didn't drink any water, and
I've done that, yeah.
And when I realized, I said, no, okay, let's take a break now. And then when I take a break, my body really shut down, and it's very difficult to carry on, but it's all for the pictures, for science.
Well,
So how you do?
Good news.
Go ahead, Molly.
On the topic of Arizona, one of my friends and I, we just purchased 9 acres outside of
Nice.
We're really excited.
Oh yeah.
Nice. The
So
Molly and
How far outside of Tucson?
About an
Yeah.
hour and a half east, near the town of Wilcox.
Oh, okay.
Okay, I know where it is. Sure.
That's almost to the border with New Mexico.
Yeah,
I've
it's
heard
over
the
there.
border is a pretty dark area.
Yeah,
Yeah.
it's on the other side of the mountains from Portal, Arizona.
Okay.
And the skies are Bortle 2. It's like 20 what was it like I think the sky magnitude was like 21.97 or something like that. Very, very dark.
Yep.
21.9 is Bortle 1, I thought. Anything above 21.
I think it's 22 is the
Okay,
cutoff.
is
I
Bortle-
have to go check, but
yeah.
it's
Yeah,
well
say
done.
that's-
Yeah.
You're probably Bortle 1.5.
Yeah. We're just it's
You're just
it's probably darker than Texas Star Party because we're not gonna have all the oil rigs in the area.
I can guarantee you it is.
Yeah, so
Yeah.
we're really excited. We're gonna at
that's-
first it's
that's
just gonna be
dark
like
enough.
a campsite, but eventually we want to build a remote observatory out there.
Yeah, well, we're all coming. Just so you know, we're gonna
Yeah, we
hold
can,
one of these
have
star
a-
parties
Yeah, we
from
can have
Molly's. What are you gonna call it? You've got
we haven't named it yet.
yeah, Molly's some you've got Astronomolly, so we're gonna something and that's gonna be in there. Astronomolly Ranch or something.
That was a beautiful sonification. It's really cool.
Whoa.
Yeah, I heard that a lot a couple days ago that NASA published.
Yeah, I thought I saw it too. I don't think I heard the sound though.
So speaking about the dark skies, I didn't mention it, but we're here in Oracle, on a good night with not a lot of junk in the air. We're 21.5 plus, so
Yeah, that's
can be really
anything.
nice out here.
Well, anything 21, Milky Way shows up. The twilight hasn't ended yet, and the Milky Way is pretty
Yep.
bright.
Yep.
So I see that it's time to get the camera out and spend the night seeing what I can get.
Yeah, I'm extremely excited about it. So we're gonna try and go out there in February and do some camping and kind of get the lay of the land. So
Awesome.
yeah, I'll bring some of my gear with me, so I'll be sure to take some good pictures.
Looking
great.
forward to it.
Well, Scott, I can show this image of the Pelican Nebula real quick.
Yeah, why don't you? Why don't you? And then
I
we'll
need to drop off, everybody. So
take care, Mike. Thank
Star
you.
Party. Thanks for having me.
Thank you.
Good
and
night.
Mike.
Appreciate you coming.
It's a pleasure,
Um,
Mike. See you.
Yeah, so I transitioned my main telescope, the 8-inch Schmidt-Cassegrain there, over from that quasar to tonight's main imaging program, which starts with the Pelican Nebula. So this is the Pelican Nebula in hydrogen alpha, and those you can see the antennae that I was kind of talking about, and I guess you can really kind of see one there. There's a couple. There's another one or two. And this is a single 10-minute exposure. I'm not doing live stacking here. This is just a single frame as it comes down.
10 minutes.
Yeah.
Wow.
Beautiful.
Yeah. It's a lot of hydrogen there. It's just off the east coast of the North America Nebula, so kind of in that same complex up in Cygnus. It is about, let's see. So I'm gonna see how far away it was. 2,000 light years away, and is 30 light years in diameter. Like, this is a nebula that is like 60 times larger than the solar system, at least, depending on how you measure the width of the solar system. And yeah, and there's just so much really cool detail that's been blown out by shaped by the stellar winds of stars that are in that area.
Right.
very nice.
Very
Yeah.
cool. Very cool.
Thanks.
Yep.
Yeah. Oh, I came
Nice
up
to
with the
see
name
live
for you.
images coming down. And
Yeah.
it's something you did point out to Molly that, about looking really, really far away. I mean, billions of light years and recording data. That is something that's within the realm of amateur astronomy. And, so to think that your backyard telescope can capture that light and, and you can stretch your equipment and your mind and your understanding, to those kinds of distances. It's utterly amazing. We are living in the golden age of astronomy. I say it over and over, but this is it.
Yeah, and when I was looking up some information on some of the quasars I was hoping to go observe tonight, one of them, it's currently more along the lines of probably magnitude 17, but it had a sudden brightening to magnitude 12 back in 2016.
Oh.
And it faded over the following couple of years. So I didn't get to dig into what they thought caused that, but imagine a galaxy from our it's like that one was like 8 billion light years away, I think, brightening to like brightening by 5 magnitudes.
Man,
like what kind of physics?
What's going
happening
on
in there?
Yeah, right.
So I want to go read up more on that. But yeah, 12th magnitude is certainly within the range of being able to see it visually. And it was probably caught by an amateur, because we're imaging these things all the time. It's like, that's a lot brighter than the last time I imaged this.
Sure.
Sure. So yeah, there's stuff even in ancient distant galaxies, there's stuff changing all the time.
Tarek, watching on YouTube, was interested to know what scope and camera you're using, scope, camera, and filter that you're using for this image.
Yeah, so this image is the telescope is my 8-inch Schmidt-Cassegrain from Celestron. I'm using an f6.3 focal reducer. So it's got an effective focal length of 1,280 millimeters. This is with the ZWO ASI 1600 mm Pro camera. So the 1600 monochrome camera from ZWO. And this is the Optolong 3 nanometer hydrogen alpha filter that I'm currently borrowing from Optolong.
Excellent. Okay. Well, up next is Tyler Bowman. Tyler is the host of Focus on Astrophotography. He is one of the senior tech people at Explore Scientific. He's involved in product development. He's involved in QA. He's involved in many things in our company, but we're very lucky to have him. And he is here with us tonight from his home observatory. Tyler, it's all yours, man.
Scott, I guess I got a promotion. I didn't even realize it. Yay me. I want to thank everybody that was able to show up. Adrian, Molly, Mike, Karim, of course, David Levy. I wish Jerry would have been here because I know he had a great presentation to do. But a little bit about me. Scott basically said it in a nutshell. I help customers get started. That's what I do for Explore Scientific, and I am imaging tonight. But I kind of wanted to go over some basics of do's and do nots. And Molly's going to hate me because I'm imaging a target that she's wanting to image. So we'll get to see that here in a little bit. Behind me, I don't know if you'll be able to see it very well, is my IXOS 100. Now, I use this as my portable setup. Now, portable, everybody wants it to be lightweight and easy to assemble, and that's what this is for. I have the 2-inch tripod legs, which you can't see, I'm aware of, and I can carry this around in a backpack. It's holding the ASCAR FMA 230, I believe, which is 230 millimeters of focal length with a reducer, which is a 50 millimeter lens at the top here. I also have a guide scope, the ZWO F4 30 millimeter with the ASI 120 mini. On top is sitting the ASI Air Plus, which is the newest Raspberry Pi that ZWO came out with a Wi-Fi antenna. But I wanted to see if it was able to do full frame. I'm using the ZWO 6200 along with the Optolong set, full Optolong set of, I believe the hydrogen alpha is 6.5 LRGB, and I believe the O2 and the O3 and the S2 are 7.5s, I believe, or it may be reverse. Anyway, but some do's and don'ts when setting up telescopes that I've learned over the years, and also what you do and do not do when you're messing with monochrome cameras. Some things that I've learned the past week with monochrome cameras is do not change filters or swapping them in and out with different sets. Don't do it. You're creating more problems than you want to. You're going to involve or get more dust motes on everything, and you're just going to ruin your whole night's image. The flats will not be able to calibrate correctly for the lights because of you swapping your filters in and out. But with mounts standpoint, you always starting out is want to make sure your tripod's level. The reason why you want to make sure your tripod's level is just to make sure that you are going to get good balance and you're going to get good polar alignment. Because if your tripod is off just a little bit or out of balance or out of kilter with the ground level, it's not going to get good tracking. And then you'll want to obviously polar align with the Falieres or the NCP with your current latitude that you're using. There's softwares that are out there. I'll go over those here in a second. The ASI Air does it. It has a polar alignment feature. SharpCap does it, which is free. I think it's 15 for the year or 18 for the year. And they have their own, they just came out with Plate Solve. You're able to take pictures. It's great for planetary. It does polar alignment. It does focus assistant. It literally does everything that you need. If you want to go the cheaper route, excuse me. And you also want to make sure that when you polar align or when you balance I balance in the central axis. Some people balance east heavy. Some people balance west heavy. I balance dead central. I find better results that way. In my opinion, I'm taking away variables that I would possibly introduce to the system. But again, everybody has their own thing. I'm not judging you for it. It's just what I like to do. Recently, I've had back surgery I think it was 8 weeks ago. And hang on, I forgot you got a screen share. I keep forgetting this. Screen share. We're going to do the screen here. That way you can see everything. This is my backyard. Now, I know we've talked a little bit about light pollution. You can see some constellations. You can almost see the Big Dipper coming down. But this way is north to Springdale of where we're located. You can see a giant light dome. This thing is huge from where I'm at in my backyard. My Bortle scale is, I believe, a 6 and a 7, give or take. But I can see the NCP for Falieres from where I'm at, and that's all I need to see. Because I have my pier set right here in the backyard, which is 6 or 30 inches deep at 16 inches around. Some people might think that is overkill. It is for here, because our frost line, I believe, is just 12 inches. So yes, I went way beyond the frost line, but I wanted to make sure I wasn't going to move. And it's sitting, there's an Ioptron CEM60 sitting on top of it with the Explorer Scientific FPL 53 at 140. And on top of that is an Eagle, which is kind of like a Nook computer with the guide scope sitting on top. Right now, I'm imaging currently the Heart Nebula. Can everybody see that? I can't tell.
Yes.
We can see it.
Yep.
So, Molly, I'm sorry.
For a while, I somehow had Molly spotlighted while she was eating her dinner, and you were explaining your presentation there. But yes, we can see the Heart Nebula there. It's very cool.
So that one's coming up for me later this evening. It's the second target I'm doing tonight.
Correct. Yeah.
So don't worry.
Okay. So I'm currently imaging with the ES 140. I got the 2600 monochrome with I believe the name is Antilla Pro filters. This is obviously a 900 second shot of just HA right now. I plan on doing a full SHO palette on it. And I believe I'm getting I'm going to take 45 and hopefully make 40. I'm going to then do 03 next, which it's not going to be tonight. It'll probably be later in the week because this is taking forever. I didn't realize how long 900 seconds was. And then I did the math. I was like, oh my Lord, it's 15 minutes, a single sub. So I'm going to be out here for a while. Guiding wise, the reason I went with the pier is because I'm able to get 0.2 on the pier.
Awesome.
Now you can get this anywhere. As long as you're able to get, I'm going to circle back to a level tripod, a good polar alignment, and good balance. This is what you can achieve with any mount. With this particular mount, the IXOS 100, I'm able to get 0.4 on the total RM or the RA oscillating.
Mm-hmm.
So it's easy to achieve. With a $400 mount, Adrian, you can achieve amazing guiding. Some people like to use the little sky guiders. They're great. They help. They definitely get you into the hobby. But if you're wanting to up your game up to something that's a little bit still portable and it's not overly heavy, this would be my next bet. It really would. It's still within the same price range as a Ioptron Sky Guider, the Star Adventurer,
Yeah,
the Skywatcher.
the one that I have.
It's all they're in the same price realm, but you get a little bit bigger of a payload back here.
Mhm.
And it's the ASI Air is it configures very easily. You can you can use an iPad for it. You can use SGP for it, and it's easily configurable. And that's the reason why I love the portability of that particular mount, because the one out there does not move. It stays. I have a tri-pier if I ever decide to take it off, but I'm probably never going to because I like the way the guiding's going. So that's why I like that one back there, because I can literally throw it in the backpack and I can take off with it. That's why I love it. I really do.
One thing I would have to start doing is turning my images into composites, unless there's a half sidereal tracking mode, because I use that all the time to take single shots of a scene. I go 30 seconds. Yeah. And it kind of balances the best of both worlds thing. But I do have an image that I did where I was able to get 2 minutes somehow. It was early on with that unguided. I had 2 minutes of a fairly faint Milky Way that I was able to then brighten up, and then I just did 2 minutes of the lake in front of it and managed to stitch them together. That is the one image that showed me, you can do composites. I think a lot of the top guns in the nightscape business do composites more than they do single 30-second shots, just because of they can turn a Bortle 4 Milky Way into looking almost like Bortle 1, because then they can track it and then they can lay in the image underneath it. So that is something I did start looking at that, and I will probably be getting a hold of you soon.
We have specials going on right now with Black Friday. I'm telling you, man, now's the time to do it.
Well,
I don't mean to do a sales pitch, but now's the time to honestly do it. It really is.
I'll be getting a hold of you, and those that are watching the live stream here will probably get a hold of you as well. And if I do get it, I will.
And if there's any left, Adrian, we promise to get you one.
Yeah,
I appreciate
on the side just for you, Adrian.
Yep, that may be coming soon. So I'll go back on mute and turn it back over to you all, but definitely interested.
Thanks, Adrian. Okay, all right. So up next is Jerry Hubbell had to duck out for the night, so we'll go straight over to Annie Scarborough. Annie? Hey,
everybody. I'm going to talk a little bit about imaging with or doing astronomy with your family. I currently right now I have 4 children. I have three older adult children, but I have a 4-year-old that when I started working in Explore Scientific, I started noticing some things about him. He was very interested in the moon. We would be driving during the daytime and he would say, "Hey, Mommy, the moon, and I'd think, I can't even see it. And so, but then I would be turn my car around to go another direction and see it. And it sparked something in me that made me realize that he is seeing things in the sky And he's starting to recognize those things. So I decided to go ahead and take the opportunity to try to start teaching him some things whenever Tyler and Scott and everybody at work pretty much made me take a telescope home.
Right. So, okay, we kind of just jumped into this talk here to give you a little bit of background. If you're not familiar with Annie is, she helps manage the Explore Alliance. She does all the membership services and she makes sure that, that members are getting all their benefits. In addition to that, Annie is a customer service representative. She is learning astrophotography. Her background is photography. She has a good background in photography, similar to my background. I started off as a photographer, then got into astronomy and stuff. So, but every day she's up to her elbows and up to her neck in all things astronomical and equipment and solving problems and stuff. So, and she and I have talked quite a bit about her family and the excitement that they've had in getting involved with that, since now Mom works at a telescope manufacturing company. So there you go.
Thank you. I'm sorry, Scott. I'm really new to all. 100% new to all of it. So so when I started at Explore Scientific, I had never touched his telescope. I didn't know. I honestly never even thought about touching a telescope. So I had a lot to learn, and boy, it really sounded like Charlie Brown's mom when people started talking at customer service. So I was like, am I ever going to learn this stuff? But I've learned quite a lot, and I know there's still more to it. And so it's been really neat to watch. My son's name is Daxton. It's really been neat to watch him spark that interest to spark in him. And so when I first brought home a telescope, which was our FLAR 102-1000, it's a 102. It's a 102 with a 1,000 millimeter focal length. And so we brought that home. And I brought it home, and he saw it, and I got it out one day, and I said, "Hey, Bubby." No, he said, on the way home, he wanted to see the moon. I said, "Hey, Bubby, you want to see the moon up close?" And he said, "Yes, yeah, I do." And so that was his first time ever seeing the moon up close. And he just, ever since then, anytime he's with me and he sees the moon in the sky, he's like, "I want to see the moon." And so, of course, like any mom, I go home and drag my telescope out and get it all set up for him. And so we went from that 102.
We lost your voice there, Annie.
I thought it was my internet for a second.
And she froze up. Today it's just been a crazy day for the internet.
6 millimeters. It wasn't very big at all. And so, you never can tell with the child, like if they're actually seeing stuff, because, at 4 years old, they're like, "Yeah, I'm looking through it," and their eye is actually closed. And so I learned really quickly. I asked Tyler, I wanted a bigger eyepiece to bring home. And so he gave me a 62-degree eyepiece, and I brought that home, and I immediately realized that the reflection that was going through the telescope through the eyepiece was then reflecting on his face, and I was able to tell if he was actually viewing something, because he would stay farther away from the eyepiece. So that's one major trick that I use with him as a little guy, to be able to see if he's actually viewing things. And then now we've gotten into etiquette with telescopes, about not grabbing them, when he climbs the little step stool, to keep his hands behind his back and to not touch anything, so that way that's not all over the place. But I wanted to show y'all some pictures of him viewing. Let me see if I can try to.
And how quickly is your son Dax, absorbing astronomy? What is that like?
He is, can you see that?
Yeah.
Okay, so this is him the first time viewing with that FLAR 102. He is really, really quickly. So let's see. We moved to the ED80, and then one time we were out way out in the middle of nowhere. I can't remember the name of the town. We were out in Arkansas, but we came out of this building. There was nothing else around except for this huge building, and we got out into the field where we were parked at. And I said, "Hey, Dax, look up." And he's like, "Oh my gosh, I can see space." So he's, and now he asks to see stars when we're looking at stuff. He'll point out things in the sky that he wants me to turn the telescope to. And so this is him. This is our house. I have a really small house. I live in Prairie Grove. I think Arkansas. I think I'm at a Bortle 3 where I'm at. But
photo. That's great.
This is him. You can see the reflection in his eye. This was actually taken at night. Of course, an iPhone loves to do the whole little dark imaging thing, but this was taken at night. You can see the reflection on his left eye, but his right eye is open, and so because of that, I'm able to tell him, "Hey, move this way," or I'm able to get him more lined up with it because we're using that bigger eyepiece. And then this is him learning the etiquette of standing at a telescope, to not touch it or grab it, and so that way it's not moved and it's staying lined up to whatever you're pointed at. Obviously, we have quite a bit of street lights and stuff around, but he's still able to see things. He's and point them out. And so he's real quick. We just traveled to South Carolina, and we're driving, out in the middle of nowhere. And I just rolled down the window and I said, "Hey, bub, look out the window." And he's just like, "Oh my goodness, there's so many stars," and so he's absorbing it quickly. And it's kind of funny. I feel like at times I can't keep up. I feel like he's learning faster because I want him to be able to see more and planets and things like that. And so I'm not learning as quickly as he probably could, but he's soaking it up. I mean, absolutely soaking it up. Yeah. He has a Galileo scope now that he asks to get out all the time. This year for Christmas, he's going to get some binoculars and his own telescope. I mean, he knows. He took a little mini telescope to school, to his daycare, to show that off. I mean, he is soaking it up, and he's loving every minute of it. So
wonderful. I love those images. Great.
We look forward to him doing a presentation here soon, because we have kids that soaked it up. Yeah, we have young ones that just love the night sky and have gone into it.
I am eager to one day to take him to a dark site so he can actually view what the true sky is like without any light pollution. And so I think it'll be an amazing experience, not just for him, but for me, because I've never seen one either. But if you place that stuff in front of them, and they're just like little sponges, they'll soak it up and they'll learn. And it's seeing past what's right in front of them. Even though he's 4, he knows that he knows that there's more to our planet than just our planet. Like, he knows that that's space. He knows that there's other things out there. And it's really neat to watch him, get excited about that and really interested in it. So,
that's very good, because it's something that can be grasped even as a 4-year-old, that we're not alone, as long as that's how we're presenting it. Save our planet by showing that it's not the only thing in existence, and maybe there could be some good to come out of that. So good job, mommy.
Thank you, Adrian. And that makes me think about, there was one day we were talking, because we'll talk about stuff in the sky, and one day we were talking about the moon, and there was a planet, I can't remember which one it was that was near it. And I told him, because of course I got out my Star Walker app because I'm still learning. So, and I told him what it was, and he just was floored. He's like, "Oh my goodness, that's whatever, Saturn, Jupiter, whatever it was.
It would have been Venus, and then it would have been Jupiter before the eclipse.
Yeah.
Venus
Yeah.
was near Crescent, and then
Yeah.
it was a little bigger,
Yeah.
and Jupiter was near it. So
Yeah.
yeah,
No,
one of
he,
those-
I mean,
one of
for
those
him,
planets.
one of those. But at Thor, for him to understand, oh, that's another planet. It's a planet. It's not a star. He was hit, and he would tell everybody for a week, a couple of weeks. I saw such and such, and so he really loves it. He really loves it. So I'm excited to see him learn. So.
Great.
Yeah.
Wonderful. Okay. All right. So,
Well, so does Annie get a raise now for showing family the stars in the night sky? I'm trying.
take it out of your paycheck, okay? So,
I'll have to ask my employer.
no, I think it's wonderful. When we have people that work at the company get involved in astronomy, and they don't just see it as a job, but they see what's what is happening with our community, with seeing the journey that they're on, and their explorations, their personal discoveries, and to see that carry over to people at work, where they're taking telescopes home and enjoying it and sharing that with their friends and family and stuff. That goes beyond just the money and the and just the mechanics of running a business. So I guess I could have been selling washing machines and probably making a lot more money doing it. But I find selling telescopes and devices that you can explore and make discoveries with far more interesting and rewarding. So I'm glad I'm involved in this business, and Annie and Tyler and Jerry, for that matter, all are very they get it, and they're into it, and so. That's great, and we hope Annie is with us for a long time, and she'll, as we grow, she'll grow too. So
and that's the great thing about Explore Scientific. We're not you're talking about selling telescopes, but I always tell our customer members we are 100% about educating and making sure you are successful in your hobby. We're not just about our products. So we want to encourage people to learn and grow in that. And that's what I'm trying to instill in my son. And so, I want him to grow and learn in that, not just sit behind an electronic device. So,
right.
Yeah.
Excellent.
You all are making me wish I lived in Arkansas.
Yeah.
Sign me up. Get me an application.
Yeah, we wish you did
I
too.
want to work for Explore Scientific now. But I'm in Michigan. I don't know how that's going to work out, but
it's just a plane flight away. So,
okay.
That's right.
Well, I'll keep that in mind.
All right. So up next is Dr. Marcello Souza. He is running the Young Stars of Tomorrow program. But Marcello is trained as a cosmologist. He is professor of astronomy. He is an icon of educational outreach in throughout Latin America, and he's been involved with UNESCO. He's been involved with so many programs. He's helped young people reach for the stars, not only through their regular educational programs, but through star parties, through special events, through having kids build CubeSats. The list goes on and on. But Marcello is a great friend. He is the co-editor of Skies Up magazine, Global Astronomy magazine. And Marcello's with us tonight. So Marcello, how's it going?
Hi, nice to meet you. Nice to meet all of you. It's a great pleasure. Thank you for your kind words.
Yeah, it's all true.
I hope I deserve.
I haven't done it justice, really, because you are an amazing individual, and we're all lucky those of us who know you personally are very, very lucky to know you. And the students that are affected by you, their lives are changed.
Thank you. I hope so. I hope it, but we have many students that are very motivated now with the projects that we are developing. This make not only me but all of our group very happy. For some way, we are doing something that can change the lives of these students.
Yes.
It's quite. We talked earlier about the. We are concerned here about the participation of human here in Brazil. Most of the girls in science, and then I make a short research and I have data from Brazil about the participation of women. Then we can see our problem here and the importance of scientists like Dr. Rosalie Lopes, that is a Brazilian that works at NASA. But
yes.
Important to motivate the students. I will share here this
great.
Then you see what is the problem here in Brazil, because you have now many women in universities. You can see here the presentation. Yes.
Yeah, we can see your presentation.
Okay,
yes.
Thank you. Here is the women's with university degrees for age. From 25 to 34, 25% of the women have a university degree, and the men's only 16 here in Brazil. This information from Brazil. From 35 to 44, 24. This data is from 2019. Before the pandemic. From 35 to 44, you have 24% of women that have a university degree and 70% of men. From 45 to 54, you also have more women with university degrees here in Brazil. 19% of all the women with the 45 to 54 ages, you have 19% of the women with university degree, and men 13%. And from 55 to 64, we have 15% of women and 13% of men. Then this appears that you have more women here in Brazil with university degrees. But when we look, I'll show also what is changing. This is what changed in the years. This is the percentage in relation to the total number of higher education professors. Now, in 2019, 46, almost 47% of the professors in university are women. Then,
nearly half. That's great.
Yes, almost half. But when you look for the participation in STEAM careers, we have this. We have most of the women are in social sciences, social services, pedagogy. And when we look for STEAM careers like engineering, computing, technology, we have most of them are men. I have here the percentage. You have in computing, you have only 13% of women from the total. We have almost 87% are men that work with computing. Engineering, we have 22 that are women that work with engineering and the physics, chemistry, and we have almost 80% that are men. Then our problem here is to motivate women to study science, to study engineering. Then this is importance of Dr. Rosalie Lopes and the other Brazilian scientists to motivate the students, the girls in the schools. This is our problem here in Brazil. All the careers
is a
are
problem worldwide, really. There are advances in various countries, but I think in general that this story is repeated again and again. And so it's I think it's our duty to encourage young girls and women to get involved in science and engineering.
but it is necessary and important to do this. And I hope that in the next years, we have more students that are girls here in universities. In high schools now, we are working now developing projects that we are visiting schools. Then we are just after the pandemic period here in Brazil, because the schools opened in August, the private schools, and the public schools only opened in October here in Brazil. Then we began the project almost in the beginning of when the students arrived again in schools after almost 2 years without participating in any activity in schools. Then I will show now the pictures here in schools that we are visiting. I only show a few images, but we already visited 13 schools, and we have contact with more than 200 students, and most of them are girls.
Wow.
Yes, I believe that's what's happening because the boys, they need to work because we also have economic problems here in Brazil. Then when this happens, most of the boys, young, they begin to work to help their families. Then most of the students in school now are women here in Brazil, girls. Here are some pictures that we took when we visited schools. You can see here we have 15 students in this class, and 9 of the students are girls. It's something that is changing here in Brazil. But I don't know the reason. I believe that the reason is because the boys need to work earlier because of the economic problems. But we are all the schools that we have used in different cities is the same thing that we see. Here you see two. This is making us very happy. 2 girls that received the prize for the best projects about astronomy.
Oh, that's great.
We are giving prizes in every school for the best projects. And then 2 girls, and we have 2 students here that participate in our group. Isabel here is responsible for the programming, to teach programming for the students.
Okay.
And Caroline is helping, is presenting about the develop a project with the students to develop animations, cartoons, with the students' arts.
So Marcello, do you think that with initiatives like Young Astronomers for Tomorrow, do you think that we will be seeing a lot more women involved as professional scientists and professional engineers in this generation?
Yes, I believe so. I return here. Isabel here, she participates in the activities. Now she is not with the shirt. She has a shirt that says that code is for a woman. Then she talks every day that you have activities. She says the same thing for the girls, because they can participate in programming, engineering, what they want to do.
That's great.
That is what we try to show to them. And we are inviting also scientists to talk with them. You already participate in one of the meetings with the students. And we believe that in any way we can help to motivate the students in the region where we live here in Brazil. in the north region of Rio de Janeiro state. And we are also developing public activities, even with the pandemic, because we are finishing the pandemic. I believe so, that is finishing here in Brazil, the period, because we have more than 70% of the Brazilian population now are vaccinated. Then we are trying to return the activities. And we did 2 Sundays ago, the Saturday and Sunday, we return with the driving for astronomy here. Now we have a super production. I don't know if I can say this, but we have characters there. It was a big program for kids about astronomy. It is a driving about astronomy, only about astronomy. We have telescopes to show the live images of the moon, the Saturn, Jupiter, and the Venus. We show live.
This is not the first time Marcello's done this drive-in event. This is held at a mall. You drive your car in like you're going to a drive-in movie theater, okay? And they show these astronomy programs, which is just fantastic.
Yeah, I have a video here that shows what happened this time.
Okay.
I don't know if you can hear the sound, but I'll take. Let me see if it's possible to transmit the sound here. There's only a music here. Here is the entrance of the drive-in. We have more than 40 cars participating in each session. Is the biggest shopping center of our city. We have telescopes and have a lot of cars there.
Yeah.
And now we have these characters that participate. The people participate from their cars.
And what a wonderful way to do, something safely in this pandemic. People.
And they show here images. And I think that's not supposed to see the sound, but it is many have kids with T-shirts about astronomy that participate. It's a big success here in Brazil.
Yeah. Oh, that's wonderful. That is wonderful. I don't think this is being done anywhere else in the world, Marcello. This is fantastic.
This was a great experience for us, and we received the invitation to do more sessions of the driving, and probably we will have a new experience. But this was a separate production because of the shopping. They have the characters of. Then we have music is about astronomy. Then involved the kids. It was a special project for kids, for the participation of kids.
Right.
We did 6 sections. In this last experience that we had here.
That's wonderful. If there are Oscars to hand out for people who do astronomy outreach, Marcello, you would certainly get one,
Thank you.
It's fantastic. Now, earlier, Marcello also talked about Dr. Rosalie Lopez from the Jet Propulsion Laboratory, and NASA will be giving a presentation earlier tomorrow to your students. What will she be covering? What will she talk about, Marcello?
About her experience.
Yes.
And she will have we choose the best students that participate in the project in the schools.
Yes.
And these students will be in the same room with her to talk with her live. Then
that'll be fantastic. I'm sure they're very excited. It's wonderful too that Rosalie Lopez gives so much of herself, and her time to do these things. Of course, she is also from Brazil. That's her native country, and she's been working in the United States as a scientist for a long time. If you don't know who Dr. Rosalie Lopez is, you can look her up on Wikipedia. but to my understanding, she is the world's greatest discoverer of volcanoes in our solar system. And so she is a world-renowned planetary scientist and a huge inspiration. Tomorrow at 4 o'clock Central, Rosalie will be on the Explore Alliance program talking to Nicole Oliveira. She's an 8-year-old research astronomer. She has been called the world's youngest astronomer. And so Rosalie will be translating Nicole's story for us, and I think it'll be fantastic. And so I'm looking forward to that that whole program overall. So, Marcello, thank you. Thanks for sharing your drive-in experiences, the latest things going on with young astronomers of tomorrow, and you know, and also explaining some of the challenges of women in science in your country. But I think everywhere that people should encourage, you know, half of the population of our planet to, you know, to find the ways to express themselves through science, through engineering, through technology jobs, because there's many brilliant women in the world that in decades past, of course, were not given the opportunities. And so there's a lot of work still to do. It's better, but much, much more work still to do. So thank you very much, Marcello.
It's my pleasure.
Thank you. Up next is Nico, Nicolas Arias, Hammertime with Nico. Nico's in Argentina. He is someone that startled all of us as amateur astronomers as he showed us stunning astrophotography done with his Dobsonian telescope, with no motors, no computers, no electronics, just a camera attached to his Dobsonian while he guided it by hand. So he continues to do that kind of work now. And Nico, are you with us?
Hello, how are you, Scott? Hi, everyone.
Yes.
¿Cómo anda, Nico?
¿Todo bien? Okay, well.
Hola, Nico.
Hola, César. Well, we have a really nice show tonight, a beautiful presentations, and the topic tonight is the Lookback Time. And I think that we several times end up talking about the distance, about the time, and the machines that we have. As my dog here, I'm here in my patio, in the Astro patio, and the lookback time is something that always wonders me, because I observe and I start just looking up and thinking about okay, that happens a long time ago, and probably is not there now, or maybe change or whatever. And as you know, I love to make all with my Dobson. I have an equatorial mount, but I love the Dobson moments. And so tonight I will show you some live images with my QH.
Live images. Your Dobsonian.
Yes.
That's awesome.
And talk about the time. I love the double stars, so I will start with a double star in Eridanus that is called P Eridani. That is a double star that both stars is there are about 25 or 26 light years distance. So let me share my screen. Okay, are you seeing?
Yes.
Yep.
Okay. Well, let me find my way with my hands, obviously. And
there it is.
The double star. And these two stars, it's an orbital double star, and the orbit is around. Have it here. You can see this is the partial orbit with all the observations, the historic observations from 1825 to now, and the period is about 493 years. So as they are 25 light years, maybe, well, no, maybe it's an actually that we are looking how in what position those stars was in the orbit 25 years ago. So as you can see, we have here the historical separations. In 1825, it was a 2.5 arc seconds, and now they are about 11 arc seconds. So they are coursing the orbit this way from the down to the left, and now they are probably here. They're maybe at 10 arc second separation. So that is really, it really makes me think. Well, I observe or capture that yes, we are looking really the past. It's amazing, and these stars are only 25 light years ago, and now we will jump to a really known globular cluster that I showed you a few GSP ago. That is 47 Tucán in Ghana. Let me go there.
Nico.
Yes.
The 7th of December, we have to go to Alberti again.
Yes. And there we have the 47 Tucán.
Nice.
And now we are looking like 16,000 light years. So this
Wow,
not only we are looking to the one of the older stars of the galaxy, but we are looking 16,000 years in the past. So this is really shocking. And there is another globular cluster really close here that is in GC 362. I think if I'm not wrong. Let me find. Here we have.
It's really unnicing without the motors.
It's a contact ring work. Let me find that the shine of the screen is flashing me. Okay.
I can't believe that you don't use motor. It's incredible, really.
Yeah, there it is. It's really entertaining. And this globular cluster is about 27,000 light years distance. So we are much on the past. It's really shocking to think about this. And I used to go out with my dog and start observing, and then I found myself like 20 minutes just looking up and thinking about this. So well, this was a short presentation, but I love to share and talk about this. So okay, thank you everyone. Thank you, Scott. I hope you enjoyed this.
I did. I love watching the style of astronomy that you do. Your explanations. I love that you dive into some of the scientific explanations of the objects that we're looking at. So you're a sky interpreter of the best kind, and to show us that you can do this with a large aperture telescope that is very simple, I think would make John Dobson himself very happy to see what you're doing. So I think so. And John Dobson was not one who enjoyed astrophotography, but I think that you might have been able to, inspire him. So he probably would have wanted to try it himself. Yep, that's wonderful.
It's really nice, and it's nice to encourage everyone that maybe has no a big scope or a big mount.
Yes,
isn't cheap. So if you can start with a Dobson, you can observe. But if you have a camera or a webcam, you can do a lot of things. So
that's right.
let's do it. Yes,
that's right. That's right. And just do it. That's right. That is a very important thing that all amateur astronomers should do. They should try things. Even if people say, "Oh no, that's not the best thing to do," or "That's not the optimum thing to do," don't let that stop you, because you might just make, if you're out there getting data and doing astronomy, you might just make a discovery. Okay.
No,
and that's far more important than maybe getting the sharpest possible image of a star. So
of course, I told you in a past GSP that I measure double stars and I discover a double star with my Dobson. So everyone can do that. Yeah,
that's wonderful. That's wonderful.
Okay. Thank you, Scott.
Thank you, Nico. That's great. Okay, do we have César with us? I think he's there.
Hi, Scott.
He's there.
How are you?
How are you?
I am in blue color here. I don't know why.
You are in blue color. Yes.
Fine, Scott. How are you from your home today?
I am home today.
You moved the studio to your home.
That's right.
Yeah.
That's right.
Yeah. It's great.
Yeah,
maybe you can enjoy the show in your home, because it's I don't know if you're near to your home from the factory, but
I'm pretty close. Yes, I am.
Really? Okay.
I'm pretty close. Yeah. But today we did not have internet in our office.
Yeah.
It was a rare problem, but apparently a number of us on our program tonight had various internet problems. So I don't know if it's something going on around the country or around the world, but we're here and it's all working. So that's good.
Yes, excellent. And here tonight, I'm returned to the balcony, and it's a great night. Talking about the look back about time in from the space, from the really huge distance that we are talking about time. I choose for tonight Tarantula Nebula. And Tarantula Nebula, when we think in nebula, we think that they are normally in our galaxy, and they are at maybe 15,000 light years. But I choose this nebula because, first of all, because it's between two buildings, and I can take the pictures lights for tonight for processing. And the another way is that it's really very far away distant for a nebula, because Tarantula is not in our Milky Way, if not, it's in our that we call it accessory galaxies, that is large Magallanes cloud. And it's such, while most of nebulas, for example, Orion, I think that is at 15,000 years old, or nebulas are from 3,000 years old, like I don't don't remember if it's M27, maybe the closest nebula. And this is incredible because today a nebula, it closed at the same distance that Orion Nebula. We can see shadow of the light is in another scale. It's you know, maybe if you think for United States, you think that your galaxy is New York, New Jersey is a large Magellan cloud, and this nebula it's in New Jersey. It's not in your city. It's in the neighborhoods. It's in the suburban areas, and this is incredible because the scale, the huge scale. And talking about how was our planet and when the light started that today we receive starting to go from the nebula, we are talking about the time of the first Neanderthal, sorry, the hominids, the first hominid, the first apparitions of religious things for the first humans. Because it is the starting of the sense of consciousness when archaeologists founded from this age the first signs of religions conscience. You know, that is the idea of a god or why? Because they started to found the bones, the bodies of the bones of the body together with the sense, and in the first time of our idea of consciousness,
when humans become an age of reasoning or something.
Yes, absolutely, and absolutely, yes. I can show you now because I couldn't process the image because I have the image now, very green. Sorry, but maybe you can see. Let me share the screen. Sorry, sharing the screen is a problem in our show every time. Okay, share the screen.
It's part of the show.
Yes, you know. Yes, it's normal that if not, it's not global star party. If you share the screen perfectly in the first, it's not the global star party. Yeah,
that's right. You're not watching the global star party.
Yes.
That's right.
Yes. Sorry,
right.
Scott.
No problem. Okay. No problem.
There is the nebula, César. And there is
yes.
And plus you have blue internet today. You have a blue internet, so I don't know. It's
yes.
César Blue tonight.
Yes.
Yes. Yeah, absolutely. Yes, absolutely. I am underwater. I don't know, but it's let me know if you can see the nebula here. Hi, Molly. See you now.
Cameron Gillis says the blue screen nebula.
If you can see the stars, the huge fields, because it is in the area of
I think he has some issues with the connection.
But he left us the image. So there is the nebula, and there are a lot of nebulas and clusters there.
The core of that nebula is amazing. Also, watching with your Dobsonian and obviously taking pictures is kind of blow mind, you know.
Yes, it's amazing. And this is a nebula in another galaxy, so it's mind blowing.
Yeah.
I see. That's very cool. That's very cool. Let's see if César comes back. If not, we'll go to Maxi, and then I imagine César will come back. But give him a couple of minutes. You know, it's really cool that you three guys come on almost every Global Star Party. Yeah, I always look forward to the Argentina part of our program. You know, so I've been thinking about a show that you guys can do that's really just for South America. You know, so if you guys might be, you can talk about that. But if you're interested, I would be interested. You know, so we have some spots open now. Dr. Barth, Daniel Barth, ran his last show, and he had our Monday slot. So Mondays are now opening up. If that's something that you guys would like to try to do on a weekly basis, or or if Global Star Party is where you guys like to be, then that's I'm pleased with that for sure. So.
Oh, that would be nice, Scott. We can do it.
Yeah, I know you guys can put together a great program.
Yes.
So
any excuse is good to us to share and to laugh.
And also to meet again. You know, we made a really good friendship. Of course, we have some distance between us. Well, César and Nico, they're more, maybe, I don't know, maybe an hour. But here I'm really outside of Buenos Aires. I'm some kind of far, and when we met, like we did a couple weeks ago, with the pandemic situation and everything, we had a really good time chatting, laughing, telling jokes, and also doing astronomy. And that's of course the astronomy really joined us, but that's how I'm here talking to you, Scott. You are from United States, and I never thought that I was talking with you a couple of years ago, and I was I never talk in English alive. Only once I translate some tourist in Mar del Plata in my holidays, I remember, because he wants to buy a t-shirt, and that's all. But here I'm here with all of you, chatting, laughing, and sharing astronomy of the kind of way that everyone can do, and that's really inspiring.
Yeah, that's
and
cool.
I'm really glad.
Well,
we love it too, because you're sharing with the amateur astronomers all over the world, and they're excited to know what astronomers are doing down there in the southern hemisphere. Because it's a place we all long to be. You have the greatest skies in the world, and and so it's
we can explode that. We can. Last GSP, when it was, I don't remember his name, but it was this person from New Zealand, and he took pictures of the Aurora Australis, and Tierra del Fuego, it's more down like New Zealand. It's a little more down.
It's further south than where you are.
And I didn't saw any picture of if anybody of that place took, but I don't know if they know if they are allowed to saw that, but I think because of their latitude, it's more to the south. They're maybe going to see it more, that aurora. But
yes, I think that it's not that normal as the aurora boreal, but yes, we need to go to Tierra del Fuego to take pictures.
Yeah, a holidays and well, well, you went, Nico, a couple of months
Yes,
ago
I was there a few months ago. Yeah,
in Ushuaia.
traveling with my family. Yeah.
All right.
We have César back.
Is he back?
Yes.
Yeah.
Yes,
I'm
team
here.
Team Argentina. It's always a pleasure to be on with you three
Right.
through
Well,
the
Trek wants to know why I didn't invite people from Chile, and we do.
Yeah.
But
sometimes they can't
so
make
far, not a lot of participation is intermittent. But and then Harold mentioned that there are Chile astronomers on YouTube all the time, so they're out there for sure. So
Yeah,
they'll be here
Cesar's
eventually.
back.
Yeah, César is back.
Great.
Don't spy the neighborhood.
Yes, but was completely shut down the internet. This was because I don't know how was that, but I was completely out connection. Well, as we are talking tonight, I trying to share. Let me. I don't know if I well, here I can show you something that is the processing of guiding with the EXOS 100. Tonight exist two things here. One of this is I move, and the graphics show that I move, but the graphics when you don't have movements are for a small mount, wrongly aligned polar aligner. You have 2 seconds of movement, and that is really great. When I move, because my floor here in the balcony is a wood deck, and all is connected. Yes, here if I move here, you can see
It's
3 or 4 seconds movements, but really were great, and existed a little of wind, of course. If I go to the balcony, the winds appear. It's something that the wind follow me in my life. And another thing that I can show you. Let me see if I can share another picture. Well, the things that is that I need to process a little, maybe before Maxi, after Maxi, I can show you something processed, but very fast processing, to watch something more than the blue or green sky that I show you, because maybe for internet, of the quality of internet today, it's impossible to see stars. I don't know, because it's here in my computer, I can see a lot of stars in each light, but I know that it's really it's really difficult and not easy to show by internet, because the image is really with a green background, a really strong green background, and maybe you forget absolutely the stars that are really are pinpoints. And the mount really worked amazingly tonight. I need to make something that is a technical thing for the people. Normally we talk all time about backlash, about the quadrilateral mount. This mount is really easy to remove the cover and make the owners make the 2 things to adjust the backlash of the mount as the owner like. And this is something for me. I prefer a little of backlash more than than a mount really adjusted a lot, because I prefer something more loose, and use the mount with a little of unbalance. Here, yeah, and work very good. But if you have a little of wind, maybe you have the graphics that you say, okay, maybe you can adjust a lot. But it's, well, you know, Scott, because you manufacture the mount, that this is only for screw.
Yeah.
Remove the cover, and you can put the level of backlash with only 2 screws more, and another one that is you can adjust with a coin, and it's maybe you spend 5 minutes to make your adjustment as you like. And this is something that I love of this mount, really. Well, I'll Maxi, give you give me 5 minutes to put some calibrations, and get the green or blue background out.
Yeah.
to show something about the Tarantula Nebula. But this is a great picture, and maybe now is going to the beside the building, but was a great astrophotographic night
In Buenos Aires, in a
Buenos
very
Aires.
polluted area.
Absolutely, yes. I can count only 3 stars in the sky now. Yeah.
6
yes.
here.
Yes.
Only 3?
No, yes, I know Banfield because it's
yes,
but it's not Banfield that this isn't from in the south of Buenos Aires, but it's really near. I in my childhood I lived at only 15 blocks from the neighborhood of Nico, but actually they have a lot of LED lights in
Yes.
and it's the same. It's
the
really
lights
similar.
is reshine. That's why I hide myself here in a little patio, and I only can see the south. I don't see the east or the north, but here I have no lights directly on my eyes. So
yes, it
here
is the best.
I can find more easily some stars. I think you there with the buildings is really hard to get your eyes involved in the night. It's really hard. It's impossible.
Absolutely. And it's an advantage when you have a patio, because the patio work like a observatory where you have the walls, and this is very important to know to the people. Some people told me that live in the cities and say, oh, okay, I can see over my head. This is perfect for cities or for light polluted areas, because a big problem, a huge problem of every cities, it's that you have, for example, I receive the light from this window, the reflection of the telescope,
yes,
my
the
living
side
room.
lights. Yeah.
Yes. Now I put it. I turn on the lights of my living room to don't appear so blue. but
you turn off the blue light and start the white light. Okay.
Yes, but really, of course, that this is why it's a great tool, astrophotography, with everything that you have for people that live in suburban and city areas, because it's unable to watch something. Of course, that I use it 11 inches telescope, and you can see the nebulas, and you can see maybe some galaxies. But do you have a huge Dobson telescope or Schmidt-Cassegrain, or well, we are waiting the Vixen telescope, the 260 Scott. Yes, I'm dreaming with that OTA. Yeah.
As soon as we get one, we'll send it down.
Maybe March or yeah, this is starting from Japan now. They
It's
are
coming from
sailing.
Japan. Yes,
Wow.
that's right.
I when you told me about this is something like when you told about toys to the kids. For me,
Right.
Yes.
This is your toy.
no.
It's
I confess.
Christmas.
Yes, I confess that every one time a day, Scott, I'll go to the Vixen web page because I forget totally Vixen.
Right.
But when you I see you in the page, say, come on, Vixen.
Yeah, we're really happy to become the new distributor for Vixen products. I might have told you guys this before, but back in the 80s, I sold lots of Vixen products as Celestron introduced them.
Yes. I sold Vixen.
You too, yeah.
Yes,
Yeah.
by Celestron.
Yeah.
I forget
Quality was
totally.
great, so
Yeah,
why not?
yeah.
So I thought it would be a nice addition to the Explore Scientific line. And something else, César, I don't know if it's possible for you, but it would be wonderful if you could come up to the Northeast Astronomy Forum this April. And I hope to have lots of Vixen products.
April 2022, next year.
Next year. Yeah.
Next year in April. Okay. I don't know.
Yeah. But definitely have you in our booth if
yes.
if you're able to make it.
When in April? When in April?
I will tell you here in a moment.
Okay. I'm calling to my wife, Evangelina.
Yeah. Maybe
something happened.
Yeah.
Right.
Things happens.
That's right. It is here. I'll share the website also with the audience. It's called NEAF Expo, and this is the 31st annual event, and it is going to be April 9th and 10th.
9 and 10. Okay, 1 week
9th and 10th
after
in Suffer,
the
New York.
party in New York.
Yep.
Great.
So you fly into New York City. If you come, then I'll make you part of our team, and then you can, we'll make sure that you get settled in. So
absolutely, we don't have problems to make planes. Absolutely.
Now 3 seats, César.
Yes,
I think I got to get my passport first.
It's a business. It's a business trip for me. No problem.
Yeah,
absolutely. It's a business trip. Yeah. Yes, it's really great. What, Maxi? I live.
No problem. I think
because I need time to. I need time to 5 minutes to
stack.
Yes, to stack something, to show something more. To see something, because I try, but share with you the nebula. But I think that you told me that you see something like the sea under the sea or nothing. I don't know.
It's more like in the Lake of Bariloche or something like that. Very, very blue. Yeah.
Okay.
So I think you're going to get some data.
Okay.
Okay,
Maxi,
sorry, Maxi. Before you start, I would say goodbye because I need to take my child on bed. So
yeah, no problem, man.
Guys, have a great night,
Nico.
And see you next week. Cheers.
That's awesome. Thank you, Nico. Take care.
See you, man.
Bye.
Bye.
Or maybe next Global Star Party, Scott. No problem. We can stop here. No. Like you tell us, no problem, and I can process much better, and we can talk about the nebula.
It's all up to you. It's all up to you. So yeah, no problem.
Yeah, I think that it's better.
Okay, all right, Maxi, that sounds good. All right. So I guess we're going to Maxi at this point, right? Okay.
Yeah.
All
Well,
right.
well, thanks again for inviting me, and good night, everyone. I'm Maxi Falieres from Chivilcoy, Argentina. And what I want to share with you is kind of what I did. Of course, we had some partial lunar eclipse last weekend. I remember it was a really good Thursday. I came back from the gym, and I also came back from my work, and start to put my equipment in my backyard. But also what I did is went outside from my city, going to a rural road, from Dust Road, and trying to see this eclipse and make some pictures with my DSLR camera. But also I was controlling remote controlling the mount from that place here in my backyard, my backyard. And well, let me share my screen. Let me see. Okay, do you see it?
Yes.
Okay, well, this is a little selfie that I sent some friends.
We see thumbnail images right now. I don't see.
Oh, sorry. I had to share everything right there. So there.
Yes.
Well, this is not Darth Vader. This is me, and here behind me is obviously the moon. I have a little mount, this Skywatcher, and you know, I didn't know if I want to go outside of the city, because it was very late. It's maybe kind of dangerous of the insecurity and everything, and also I was really tired, and it was almost 2 a.m. that I have my another equipment outside. I was preparing and pointing to the moon, focused and everything. But I say no, I think I'm going nuts. And then I say, no, man, you got to go, because there's maybe one of in a lifetime. So I say, okay, I get my equipment, my little equipment, went to my car and drive almost 15 kilometers from here.
Okay.
You know, when I was traveling, I saw these big birds. I don't know how you call it in English. We call búhos or lechuzas, and there was really big. They hunt mouses at the night, and there was really big. And
the owl, sorry, Maxi, the owl
yeah.
es la lechuza. Yes.
Thank you.
Búho.
And you know, I went to this part of a farm area that is in the entering of a farm that I don't know who it is, the owner, but there was nothing there. And I started to put my equipment. It was almost 2:30 a.m. and the eclipse is going to start at 3 a.m. and 5 minutes, something like that. So when I was searching and taking pictures of my another equipment with the 8 inches and controlling remotely, I was taking pictures of this of course, this is processed, stacked and processed before the eclipse started, because what I want to do is a time lapse with this equipment and also with the DSLR. And then more later I will show you some videos that I did. Well, in this case, it was really detailed, the size of the brightening moon. And well, here's a snapshot or screenshot that I did of my cell phone. You can see here is the 4G connection, the battery, but I was connected to my notebook outside of my backyard, and I'm 15 kilometers outside, and I only was doing pictures, well, in really fast pictures, taking 10 frames only, maybe per minute, and then what I want to do is stack them and process every stack to get more details. And sorry, this is a single picture of the DCLR. You can see all the field of view that I have. I use a teleobjective is 17 no, no 17 no no yeah 17 millimeters and 2000 millimeters of focal length. Put it on the Star Adventure. Well, this is almost at the sunrise. It's going to get day, but it was, like I said, it was a partial eclipse, and you can see almost the circle of the shadow on the moon, but the brightest place, it was amazing. Here's another picture, but it's a crop that I did. You can see a little, well, it's a huge bird, but at the distance, it looks like a little. And also the moon going down to the horizon, you know. Here I watch it almost complete because I have free horizon, but in my home I only have at least 12 degrees of altitude. So, well, you know, when the moon goes out, I start to see this sunrise. It was really beautiful, because this kind of picture reminds me some pictures from the sunset of Africa, something like that, you know. But these are the Pampas farm. It's very plain area.
No, it's beautiful. Very nice sunset. Wow.
This is another one. You know, I put out my camera from the mount and I start to shoot it like a machine gun. And well, you know, this was almost 5 and 45 minutes a.m. or maybe almost 6, because at 6 a.m. I came to my home, and then at the almost 8 of that morning I had to go to work. I was like a zombie, but I have to go. It's my responsibility. But I spent all night wake up.
No.
It was a huge sacrifice.
Yes.
Well, but you know, Maxi, that we are what we are talking or chatting by at the same time, because of course that I was totally sure that Maxi was wake up taking pictures of the eclipse, and I send, of course, that I send text message by WhatsApp, and we
a video from your
talking,
from your rooftop. Wow,
this is great. Well, I send you to Scott the pictures. I remember that you was I wake up too, Scott.
Yes.
yeah. It is incredible. Yeah.
Well, this is from with my 8 inches, and this is the most pictures that I could took before the building start to passing by. So it was, like I say, a partial, but you can still see the shadow and the pink area. Well, of course, this is edited, and well, here's a video that I did of of the eclipse with the 8 inches with the time doing a time lapse. I started now.
Wow.
There we go.
Beautiful.
And
Isn't that cool?
And that was the last one.
Yeah.
Let's go again. You can see the details, and I start to see the penumbra, but with my eyes in the farm area, it doesn't see it, But when the shadow starts to get over the moon, I felt like I was in a solar eclipse because the brightness started to go down, and I remember I can saw really far away because I was my eyes accustomed to the dark, and the moon was a really good reflector. But when the eclipse starts go on, it was like mostly difficult to see more beyond maybe 10 meters. And when the start to go really dark at the east, you start to see the glowing of the sun coming up. It was really a very good experience. Well, this is a time lapse with the DCLR. You can see it's more
Yes.
a better view, a field of view, and
so the exposures are compensating. I guess that's the reason why we see some.
I was practicing.
That's cool. That is cool.
It's great.
Yeah, at the end in this place when the sun, starts to goes rise up. This part of the you can start to see how it still continues, and then it's almost disappear. It's not horizontal with the field because I forgot a part of the mount, and I had to put it really inclined. So, well, this is a selfie that I took. Here's the moon.
Happy eclipse photographer.
Absolutely,
right there.
Yeah, and also the mosquitoes.
Oh my God,
annoying. At the dawn, it started to come again. But here's another one, and here's practically.
This is something that for us, for people from Texas, maybe that is normal. For us it's normal that we have all time the horizon, and we have this landscape without nothing, and maybe you drive 3, 4, 6 hours to see nothing, any mountain. I remember the first time that I know the mountains. And this is something that is crazy because I remember that I never could imagine a mountain. And for me, this was incredible because it was an experience. Because the first time that I went to Cordoba, that is in the middle of the country, I think that I was 14 years old, and for me was totally amazed by the mountains because we
I don't have mountains.
The flat area.
We see exactly. We see.
It was like that for me in Texas too. I was born in Texas, raised at various times in my life in Texas, and there's the plains of Texas are flat. I mean, really.
Yes. I can imagine the same. But for me, I remember that I was with the school to the first trip to the mountains. The small mountain because
that happened
3,000 meters.
Too when I went to Tandil for holidays to Mar del Plata. You have to passing by the national route, and you passing by through this what we don't call mountains because there is
sierras.
It's
the
sierras.
The same in the United States.
Yeah, and you know, you are also in
like
Balcarce,
Appalachians, or yes.
and when you are passing by these mountains, that they are more like mesetas, because at the top they are flats. Also, they are not.
It's the same in the
like,
Patagonia, where you have, yes, it's the
and
same.
well, you saw, you see all these rocks and everything, and I and not when you go maybe 100 kilometers outside, you start to see again the flat area. But these are the Pampa. It's all flat, practically.
Absolutely. Buenos Aires,
Santa Fe.
Scott, we are talking about
the province.
The province that we call to states, provincias. But it's the same idea, and they are not so big like states in the United States, but you know that Argentina it's comparatively is big. We have a lot of provinces where you don't have mountains. It's incredible. And you have provinces that have only mountains.
Yeah.
Yes. Well, I have something to show of the nebula. If you like to see something, Scott, if
sure,
I can have ready this. Yes. Well, let me share. It's alive. You can see the registering in alive.
Okay.
Live. Okay.
Yes.
50 or 50. Okay. This is the magic when you are cooking something and you put out, you get from the oven. Wow. You can see with good resolution the screen.
Yes, but I think remember that the processor, it's it's working and you're sharing. And
no, yes, but with this computer you don't have problem, because we use I use solid disk for that computer, and it's really fast. But maybe, you know, the problem of this is that is that I use it now to make something something fast, to show something to the audience. It's that I choose the first likes that I took in the first time of the night. Only 50 likes of 15 seconds each at 800 ISO. Well, we are awaiting the magic, you know, but maybe I produce a entire shortcut of electricity in the entire city. I don't know. I am waiting this. Please work.
Please work.
Now,
yeah.
Now, if you stuck in pigs inside, you have to maybe
go to
sleep.
Is the Deep Sky Stacker that is free. No, absolutely. But I have a lot of like of 2 or 3 minutes while we are talking. I'll be using this, the another one, the 2 or 3 minutes, guided pictures to stack in tomorrow. Now, this is only to show something, because I like to go to sleep happy to have something.
When I start to do astrophotography, I remember when I put my equipment inside, I have to saw what I took. and I have to
Ah.
process, and then I'm going to bed maybe 8 a.m. and then I'm going to
No,
work.
it's the same illusion. Absolutely, it's the same illusion that you had in your childhood when you went to the laboratory
Mm.
to get your pictures. It's really great. I don't know. Here, I
Give it time. Give it time.
yeah, yes. Let me see. Maybe I can 1 in 40. I don't know. Well, okay.
Oh,
This is stacking the 1 in 40. I don't know. Is it 6? Maybe 40. Maybe this is for the next global surprise Scott. I don't know.
Well, only
it's
you
a
can
minute.
tell.
No, yeah, no.
When I was last weekend outside of the city,
You are thinking, like, what?
But I'm feeling the magic. I feel it.
Yeah.
You can hear the drums.
Yes, but
It's
too
going
long.
on and on.
It's too long.
Part of that
my
magic is
God.
called patience.
No.
So that's
Yes.
right.
No.
Well,
Yes.
it's frustrating when the stack doesn't stack good and you have to do it
Yeah.
again, and you had to wait another couple of minutes or maybe more.
Yeah.
And well, and that's how you do, because when you see that it doesn't work, you don't say no, this is bad pictures, or I took a really bad picture. No, you have to keep practicing the stacking, because sometimes with the dark frames, with the flat frames, you can maybe get a better picture or a better stack image.
Yes.
And you have to give it time and still practicing in this case.
Yes. Something that I remember now about this illusion to spend to white something is that maybe one time we talked with Scott about the time when we make astrophotography with films, and we went to the photo house to developing our film. Maxi, maybe you remember in your childhood, maybe you remember something of the 24 and 36 pictures frames. I don't remember films. We call it
I
films.
think it has maybe
maybe you can
36.
yes.
He remembers in the history books they have.
Yeah.
Yes.
It was a craziness because we spent, maybe we had one decent pictures by completely film, or maybe normally I remember that we choose something that we call it contacts to have.
Yeah, you would get
They
a
make a
contact sheet.
copy. A
Yeah,
copy
and
of
all
the
your
blank
negatives would
pictures.
be on it.
Absolutely.
And then you could pick out which picture you wanted from the contact sheet.
Yes, a completely green pictures, like the first, Maxi, the same that you watch, like the same picture that I showed you today. You had the great picture. The greatest picture was with very very green color in the background. You choose that, and you return to the laboratory. For me, like I studied in optics, we had laboratory in our school. I had the darts, a German copy. We call it copiadora. Was a darts head with the same system. You remember maybe, Scott, the brand from Germany, Darst, DURT. I think that is a German.
Durst.
Durst, yes. and they
Yes,
have
I do.
a copy master. And I remember, I think in reverse the colors the same that we make today with the curves, Maxi, we make in laboratory with a system of filters in the head of the copy machine, where we change the colors to
Yeah, there were
subtract.
dials where you could
Yes,
adjust your
yes.
color and
It was a
hue and
craziness.
yeah.
Yes. Let
It
me
was very
share
cool.
one.
It was very
Yes.
cool.
If I have something or not.
But nothing's as cool as Photoshop.
Yes,
Yeah.
yes. No.
What? Now pigs inside.
Yeah, no chemicals, no
No, sure.
no hazardous waste, so
No, it's too much. Okay, stop
yeah.
there.
Yeah, I think César, I think this is going to take a little while.
Yeah.
No, yes. Okay, for next week, no problem.
Next week, okay.
Yes,
Next week.
yes.
If you want to
long.
send me when you stacked it, I would like to process it if you want. We can
Yes,
compare
yes,
it.
but here in my home, Agustin have in his computer pigs inside, and he's a genius of pigs inside. He can when I have likes, guided likes.
He said, "Give me that to me."
Give me that to me. Yes. No, you know that really. I have a Lagoon Nebula picture that process Agustin. I say with the same telescope. I say, okay, bye. I go to sleep, and Agustin is continuing taking pictures, and 100 ISO, really 100 ISO. I don't know how he used very low ISO, really all time.
I think it because when you do, I figure out when in this case I am using a deep sky camera. The gain that is recommended for this camera is 100. It's practically the same of 100 ISO. And
yes.
When you see the subframes only without stretching,
Yes.
you almost see the stars and everything. But when you stack and you process and do the auto stretch, it's a lot of information that you get, and you don't try you try to not burn the stars because you want colored stars. And if you go more gain, maybe we'll get white stars.
Yes, absolutely, Maxi. It's something that I don't like. I think that I see that my son don't like is make a lot of colors. And if, for example, Agustin, I remember that in his presentation, he told that okay, here is okay. The nebula was really with a very clear black background, and he told to the rest of Global Star Party, say, for me it's okay because this picture was taken from the city. If I start to put a darker background, I lost a lot of information. And this is, if I go with the same telescope to Chivilcoy, for example, I have more information. I can get a darker background, but make a more natural background from the city is a great, because you have the things like really are.
Yeah,
it's the same for it's the same that when you make an overcolor picture, or I can see every time with
you invite me the 4th of December, but of course I invite you the 7th of December is well I think you told me that you were going to work the next day, but of course you were invited because I want to go ahead to Alberti, and
Yeah.
I'm trying to do some dark
Okay.
pictures.
Maybe the Global Star Party together from.
Yeah,
From...
I was talking with Marcos, and he
Okay,
says
great.
to me that maybe
About the internet in this place.
yes, because the mayor of Alberti is going to put some security cams, and in that
Maybe
area
can use actually.
is passing by fibra óptica, fiber optics,
Fire optics, yes.
and they can get a really good connection. But I didn't talk these days, but in a couple of days it's going to put these cameras, and it will has internet connection. Maybe we can do some live view, but I want to do pictures. I only did this eclipse, lunar eclipse, but I
think that you need yes, you need because you are told me yes, send me the pictures to process.
I'm really hungry to take pictures. Yeah.
Yes, I know this feeling. I know. For me, what was the first day that I changed the 80 millimeters refractor instead the Maxutov 127. That was amazing. I have my telescope in the living room because here for me it's great to have two different OTAs, optical tube assemblies, a refractor, and the Maxutov. There are two different telescopes. Okay. Well, for me, it's okay.
For me too, I think.
Scott.
Yes.
It's all yours.
It's all.
Yeah. Thank you. No, really, thank you, everyone.
Well, okay, so let's kind of
really.
recap what happened tonight. We had we started off the Global Star Party, of course, with David Levy, and then we had Chuck Allen from the Astronomical League join us, and he relayed to us that he was a surprise. I did not know that he was working on a book about a surfer, and and this surfer's life and everything, which he's trying to finish up, which is really cool. Karim Jaffer, from John Abbott College, is a professor of astronomy there and very involved with the Royal Astronomical Society of Montreal Center, was on with us talking about Lookback Time and, the effect of all of that. Us as amateur astronomers trying to describe almost the indescribable. I mean, trying to give people a grasp of the distant scale of the universe and really just how far away we're talking about these things. We talk in terms of light years and parsecs and megaparsecs and, the numbers that range.
These huge numbers that you have to put it in a couple of words.
In a couple of words, right. And often we're talking to people who don't think in these terms. They don't think in numbers this large, and so it offers a special challenge for amateur astronomers who do educational outreach to be the interpreter of something that's pretty complex, pretty hard to wrap your head around, but to make it simple and digestible and relatable somehow.
What I do the example for the sun. The 8 minutes from the lights that come from the surface to get us, and then I start to do some little math at the talking with the people, saying, well, you have 3,000 kilometers per second. I think that's how he calls in English the lights of the speed, and you have in 1 second that's the speed, and then you have in 1 second, in 1 minute, 60 seconds. So you multiply it. Then you have 1 hour. Then you have 24 hours. And then you have 365 days that you multiply that,
Yes.
and you have 1 light year.
One
And you-
light year. Yes.
And then you
incredible.
multiply,
Yes,
for example,
absolutely.
of 4 to Proxima Centauri or Alpha Centauri. and you
That's the
have-
closest star, right?
Yeah.
Yeah, and then though the mind is going to
It's
blow.
Yeah.
already blown. Just
No,
getting
There are too
close
many
to the star.
zeros.
That's right.
Some,
And we're not
some-
even out of the Milky Way yet, right? I mean, we're to the closest star near us in the Milky Way. And so,
And also, what I say, of course, in this case, Antares, well, in this time is behind of the sun almost. But what I was telling to the people is, you are seeing a star that light is coming right now from us. It came out maybe when Columbus came to America.
yeah.
right?
At that time, it's
And
almost.
it's original. These are original photons. They're not copies of photons. They're not reflections of a photon.
They're unique.
It's the photon crush made inside that star, flying across space all this time, and we're catching it in our eyes. You know,
Yes. For me,
the
when-
connection. It's a
absolutely. Today, when I choose Tarantula Nebula, and I started to read again, you know, when you choose something and to talk and say, okay, I forget the scale that this nebula is. It's at. It's completely different for a nebula 170 miles. 170 thousand light years. And when I went to I have a story of the science, Isaac Asimov book in my bibliothèque, and I choose in the first before the history, do you have only the apparition of the Neanderthal, like something of the scale, and you are done talking about faraway galaxies. If not, the local, your accessory galaxy, that is your neighborhood. It's not it's not the cluster, local cluster galaxies. No. It's completely your neighborhood. And I say, come on, it's ridiculous. It's something that is completely mind-blowing, and something that say, come on. I can.
And also, I love to watch the expression of when the people really get it.
Yeah.
And start to feel that
a light is coming on in their mind.
Yeah.
Yes.
And they say, really? Yes, really. It's like that. It's like this. And whoa, they get shocked.
That's right.
Absolutely.
Yeah, to me is a kind of enlightenment, you know, that they have for a moment. And it's at that moment too, if they start to ask questions, you can tell that they're really, for maybe the first time in a very, very long time, they're really exploring, you know, they're really exploring because they're out there. You've taken them to an unknown place.
Yeah.
Understanding these vast distances, maybe for the first time. And now they want to know more. And that's a really important time for anyone at any age, because you are starting to, you know, that's a moment of real learning, you know. And so astronomers have a special privilege when they're doing this kind of educational outreach, you know, to experience this with other people. That's the reason why I love doing astronomy outreach. It's almost a selfish thing because I get so much energy from it. You know, when I see when they get it. You know, I'm like, okay, you know, right. But it's not something when they go home afterwards, their mind is actually really changed. You know,
they're still processing.
Yeah, they're still processing,
and still
synapses are still happening in their mind.
We say still masticando. They are still chewing gum. That thought, and that yeah.
And the people are their minds are different now because they
And
understand.
also-
Oh wow, that this is going on. If you add in that they are interconnected to the universe, not separated.
No,
not separated because you're part of the universe too.
And they realize, or what I want to make them realize, how lucky we are, and in this vast of universe.
Yes.
And also maybe you feel really tiny, but sometimes you start to think of a lot of problems of our lives, and also I have my problems, you have your problems,
Sure.
and that's the life. But you start to do step by step and start to think that no, yes, it's a problem, but I have to slow down because to the universe,
the universe is your problem is nothing.
Exactly. Maybe a photon is bigger than that problem. So
yes, it's a craziness.
Right. And when you wake up, you see these people wake up a little bit to this, and they realize, oh, what somebody said to me is not really important. Okay. And then when they think about maybe even the life cycle of a star or the life of a celestial system or something like that, they realize how short their lives are.
Mm-hmm.
Our lives to a star is like, if a star could somehow understand how long its life is, it wouldn't feel like it's long, but it would look at our life as like a spark,
Yeah. Only a blink of your eye.
A blink.
Yes. Well, here I have the nebula. It's not perfect, but maybe.
Okay, let's see.
Yeah,
the drums. The global star party.
No, it's horrible, but
it's horrible.
Come on.
The horrible nebula, huh?
No. You are taking pictures in Buenos Aires, Portal 9, almost 10.
No, yes, but
in Palermo.
It's impossible to make something here, but no.
Okay.
Because I touching the curves only with Deep Sky Stacker, and it is very bad to regulate the contrast and the level of colors.
It has to be processed.
But of course that it's really easy to make something. Maybe if I don't know, maybe guardar la imagen en un archivo.
No, it's almost saved.
Yes, I'll save in Tarantula, and we can see in Photoshop.
Okay.
Okay. I don't know where is the documento. No. No, yes, yes, 1 p.m., 1 a.m. Come on, yes. Oh my God. Here, where is, yes, imágenes and maybe.
So Cameron says you need to add the flats. Yeah.
Yes. This was only a experiment.
Yes.
You know, Scott, how I do my flats images?
With a t-shirt, white t-shirt, or
no?
This is great.
There are people that they are doing outside when the sun starts rising up. They point it to a clear area and start to take pictures. But when I did it with this camera, I have my pictures really annoying or really noisy, and I did like I still did before. I only pointing to my rooftop. It's white.
Okay.
My flashlight that you saw
on your head, yeah.
And pointed the telescope and see the parameters and start to take pictures. And that's it.
That's your flats.
Yeah, that's my flats. Really cheap flats, but
But work very well.
Exactly.
Yes.
Very cool.
I was really get me crazy because I was for the NGC 300 Galaxy. I took almost 5 hours of pictures, and okay, maybe the night wasn't good. It was 2 nights difference, but when I stuck with those flats, it really changed a lot, really a lot. And of course, I have light pollution, and that's why I want to go to Alberti, because I want to do all night that Galaxy.
Yeah.
But you know, it really gets shocked, and I say, okay, this flats works. Okay, I'm still doing inside my house when I finish.
Right.
Well, it's okay.
Yeah.
Yeah.
There we
yes,
go.
you have a lot of
Look
here
at all
of
those H2
information.
Lots of
Yeah.
many.
Yeah. Yes. I think that if I make the same, but in the good way, I have a lot of information to make a great picture.
No, but they were.
I think you already have a lot of information.
César, it was 15 seconds only.
Yeah.
This one only 50. Yes, this is not. This is only 50 at 800. Sorry.
Focal length.
No. 800 ISO 800. 15 seconds and 50 likes. 50 likes of 15 seconds each.
And that's
because
a lot.
was in the yeah. It's okay.
Yeah, it's good.
It's good. Yeah. Maybe I can get a little less of blue. No. Okay.
I think you have a good material to work with. I think
it's only now to show to see the area where you have the different color of the stars. But for unguided pictures, it's great. I think that is great.
Yes, it is. For me, it's good. It's a good picture.
Me too.
Yes, it's only a raw.
Somebody said that is the head. That's the head of a grizzly bear looking at
you. Look that. Yes.
César, remember you are in Buenos Aires, in Border 9, and you're doing these pictures pointing to the south.
Yeah,
so
that's
yes, of course.
a huge.
It's huge. That's right.
Building and another one, you have a lot of light pollution, the reflection of the wall of the building, and the
moon also right now.
Yes. For example, I don't know, one of my neighbors that you see that turn on a light very bright. Why? I don't know. You don't need that. But maybe look that.
Yeah.
Why?
Apaga la luz.
Turn the light off, please. Come on. I don't know why. Well, this is in the countryside. We have for the entire family. We have in satellite cities of Buenos Aires, you have different country clubs. We have a house from the family of Evangelina, my wife. Normally we went to the night. Many times I took pictures from the sky in this. Well, I don't know why the people love put the reflectors to the night to illuminate trees, and don't turn off the lights in the entire night. Horrible.
Well,
honestly,
here I have my two houses behind me, there's a person that has
Wow.
a pool, a parrilla, a barbecue place, and he puts 3 LEDs light like this, one above another one, and when maybe 8 p.m. or 9 p.m. he turns on, and
Yes.
my backyard is completely white.
Yeah,
Yeah.
that is called
had-
light trespass. And
Yeah.
yeah, you should be able to call the local authorities or the police and say, hey,
Yeah.
this guy is
I will get a
light
rifle.
is-
I
is
I
too
will press
loud. I
rifle.
can't sleep.
And-
Absolutely. And
Yeah.
Pekka made a great work with the light pollution in his neighborhood.
Yes. Yes.
But here in Argentina, I think that's impossible to make something like it.
I can say to
something
him,
like,
Sweden,
or say the people say, no, okay, I can get here with us.
Yeah, aiming the light down, that's okay.
Yeah.
So it's not going into your yard.
Yeah. Yes.
That's okay.
Or point it to your yard. Why you
Or
have
point
to-
it back at himself.
Sure. Yeah.
Exactly.
Back self. Yes. Entire night. Absolutely. Great idea. Okay.
All right, gentlemen.
Okay.
Well, I think with that, on that note, we will call it a night. I want to thank everybody in the audience for watching Global Star Party number 74. Our shows, as we get closer to Christmas in December, there'll be fewer of them because it is so busy during this time of year. But of course, we'll be back each week with more programming, and then in January we should be back in full swing with shows as well. Except sometimes we're going to be going to real events. We will go to the Northeast Astronomy Forum. We'll be going to the Winter Star Party. We have planned the Arizona Dark Sky Star Party that will happen in September. We have another astronomy event in Mount Wilson, California, using the 100-inch at Mount Wilson telescope. So if you'd like to have an experience using what was at one time the world's largest telescope, then you'll want to join us. So some of these things are coming about, but we always plan to do programming. So no matter where you are, you can join up with us and experience astronomy and learn new techniques and ask questions from astronomers from all over the world. So have a great night, and thanks again. Thank you, guys.
Good night.
Thank you, Scott. And
Good night.
thanks to the audience.
Thank you.
Yes, thanks to the audience. And Maxi and César, you guys think about it, because I would be very happy to do a show just for South American audience. So if you guys are interested in doing that,
Yes.
I think it would be a lot
Yes,
of fun.
we can maybe program to 2022.
And specials. Yes.
Right.
Absolutely.
That's right.
Yes.
Okay.
Yeah.
All right. Take care.
Take care, guys.
Bye.
Bye-bye.
you.